everybody, and welcome back. It is now day 2 of Certified Ethical Hacker Technical Skills in 2 weeks with Dean Bushmiller. Check out the speaker bio icon on the bottom of your screen to learn about Dean. And before we begin class, I will point out a few of the widgets that you may find useful. As a reminder, the resources widget on the right-hand side of the screen is where you can access the slides or or access the links that you may need for class as well. And at the bottom of your screen, you'll find that Q&A widget. This is where you can enter your content-related questions for Dean to address during our session. We do also have a group chat feature available, and you can use this space to type in any comments you'd like to share with the entire group here to the group chat widget. And if you have any technical trouble, I first suggest refreshing your browser. If that does not resolve the problem, type your issue into the chat box or in the Q&A, and I'll be happy to help you resolve that directly. And I do have to warn you, for those who are subject to regulated status, that the chat feature should not be used. Also, the audience may include customers, vendors, or competitors of you or your employer. And if you choose to take advantage of the interactive features available in this training, and we really hope that you will, you are responsible for any information that you choose to share. And with that, I will now hand the floor over to our instructor, Dean. The floor is yours.
Thank you, Heidi. Thank you all for coming back for a second day. It means a lot to me to see that you're here and that I was engaging enough for you to come back. So I'm very happy about that. I'm very happy about you being here. Right before class started, I tested out the new lab procedure, which is a little bit more elegant, a little bit easier. I want to talk a little bit about that as we get going today. You can, in theory, if you have your AWS account, and remember not to do it in a live AWS instance or a live region where you have regular workloads running. If you have that set up and logged in and you have the GitHub in front of you, you can potentially build up your lab from nothing at each break. Basically, if you stole each one of your breaks from yourself, which there'll be about 6 or 7 5-minute breaks, like every 30 minutes, you could build up your entire lab as we go. And the nice thing about that is I could do a little support for you. I can't do everything. I can't do all the support in there, and I have to shove that into the breaks, and I'll do that with you in the Q&A. But remember, I can't see your instance, so you have to be really descriptive. And if it's not working out for you, then what I will say is watch what I do in the labs today, watch how I run the labs, and then at the end of the day, watch the videos. Now, I'm also updating the videos on the labs themselves to show you how to get the lab started. So just know that that's going on. We are in day 2. We'll do a little bit of recap question at the beginning. I'm looking for that. So what I'd like you to do is, if you didn't see it before, scroll up or go into the resources section and click on the Mentimeter link, jump in there and post your questions. You can see, if you look at down in the corner right here, let's see if I can get to it, right down in that corner, you'll see that I have a little question thing that's popping up. I got a couple of hearts there so that I'll be looking for your questions. We will be going over the enumeration discussion. And my question before before we get started, and NP has brought it up, is have you been able to watch the enumeration video before today? And if it's no, it's okay. If it's yes, it's great. I want to get a sense of the class. So it's just yes or no. Have you been able to watch that enumeration video beforehand? Excellent, excellent, excellent. Okay, so I'll let that flow. I'll give us about 60 seconds there, and I'll get set up for one other thing here. Let's see. If you're unfamiliar with Mentimeter and this is your first time in class, pick up your phone, point it at that QR code, or you can do it in a separate browser window. The question that I have for Mentimeter And this is just, if you're doing your labs, it's either is your lab on, is your lab off, or are you watching? I don't care what the answers are here. I just need to know where your status is. So let's see. I've got 37 people in the room. Oh, I got a little bit more than that. 39 people in the room. So I have too many numbers to remember. Okay, it looks like we have a little bit more than half of the people watching that have watched the enumeration video. The code for Mentimeter is at the top of the screen here at 7301-3929, but it's also in the link. Thank you, BT. I really do appreciate it. And yes, help me out, because remember from yesterday, this is interactive. So when people are asking questions, please make sure that that you're helping along in the attendee chat. Good. And watching is okay for the labs. That's fine. Let's see. So we're going to just talk a little bit about scanning, and we're going to do a lab on scanning. It's not what you think. Okay, when it comes to scanning, I'm teaching you, I don't know if you remember from yesterday, I'm teaching you techniques on how to kind of like shift your thinking. Like I gave you a question and the answer was above it. Or I said, look inside the expsec.us for passwords, and you could go to the Discord and it would show you what the password was. So it's very simple things where you just have to shift your thinking a little bit. It's like, oh, I don't have to follow the rules, because that's one of the things that we're doing. We follow the rules of the scope of the test between us and the company that's hired us. But within that range of motion there, we don't have to follow the rules. If we can levitate, we should levitate. All right. So we're going to do a little short thing on scanning. Then we'll go over the enumeration discussion, and I will talk to you about that. I think for me, what I'm very happy about is when I was learning the material first, I realized there was this giant hole in enumeration that things just didn't get explained. And a lot of my practices today make me go to the enumeration phase over and over and over again before I ever try exploitation, because the customer is paying you to test everything. They're not paying you, well, within the scope, they're paying you to test these things in all the different ways that attackers can get in. They're not paying you because you're smart and you can get in one way. They want to know all the different ways. So then that brings us to vulnerability management, which is a very weird thing inside of the EC Council and for penetration testers. I'll explain it when we get there. And then finally, we'll wrap up the day with social engineering. I did get some people attempting social engineering of passwords from me. Did anybody in your social engineering attempts receive a password back from the system? Did anyone? Yes or no? Did anyone receive any passwords back? I did comment on some people how they were trying to attempt to catch me. I talked about what they did in their social engineering. So I'm wondering, let's see. No. Okay, so I want to tell you one little trick, and then we'll leave the rest of it for social engineering. And because it's an automated system, what you could have done is you could have sent the message from whoever you are, whoever you decided to perpetrate, because you could fake the email headers, but don't. You could send a message to the CEO of the company and then BCC every other person in the company and say, I have not heard back from these people. That's a little scary. You're talking to the senior executive. I've not heard back for these people on their password yet. Please let me know what's going on. Now, if they're real people, what will happen is it'll generate fear in them. But the tool that I use will catch and see that the message was sent to one particular person. And if there's a word that says password in it, it'll automatically give you the password. It's all set up. So, but there are a couple of people that have better accounts that if you send the word password to them, like asking for a password, it will not specifically allow you to get that information. You have to use some crafty stuff. Okay, so that's kind of what we're doing today. Let's take a look at a couple of questions that have popped in. You've been using pen test and ethical hacker interchangeably. Is there a difference between the two? Okay. Short answer is no. The problem is that the market and people who are selling services all want to differentiate themselves. They want to say, I'm an ethical hacker. We do pen testing. We do red teaming. We do advanced persistent threats. We do vulnerability management. We do vulnerability assessment. And they all want to break it apart. It's all the same stuff, because when you get right down to it, when I walk into your organization, I'm going to say, what would you like me to test? How would you like me to test it? Let's put a contract together and we will do that. When I walk into some of my financial services businesses, I don't do any penetration testing that I think of as penetration testing, exploiting their vulnerabilities. I do vulnerability management for them, but that's my definition of vulnerability management. So I think that takes care of that. Which conferences would everyone suggest should attend for cybersecurity, keeping in mind that I've never been to one? I always wanted to hit DEF CON and Black Hat. I've been to Black Hat EU while I was over there. I like Black Hat because it is very technical in nature. I would love to hear what other people have to say on that. I don't go to a lot of conferences. I do a lot of learning online because I feel there's a lot of fluff at the conferences and there's a lot of expense in actually going there. Post-COVID, I stay home and learn a whole bunch right where I am. Let's see if there's any. That's all the questions that were asked there. Let's see. All right. So we will get to social engineering. I'll show you how to do that today. Okay, so remember, in the reconnaissance and the discovery, the simple high-level version of this is what's in scope. What did they pay for? Ultimately, what you do in reconnaissance and discovery, if you have nothing and you start out with zero, is they'll probably give you a fully qualified domain name. Yesterday, the fully qualified domain name was expsec.us. You talk to Brock, and he said, I want you to test this without any tools, and then we'll move over to the next phase in the second day. Usually what I say in the scope is I find what I can find in the reconnaissance, and I pause with my customers. I say, okay, this is what I found that's in scope. That's what I found that's out of scope. It's that other stuff that's out there. The reason why I do that is because they may go, wait a minute, I want to extend the scope, because see, when they're talking to you, they're not telling you what their critical assets are. They're just very narrow mindset on what they do. Remember yesterday also what we did was we took this artifact sheet and we used this. Let me go over to the main page on this for master. We used this as a setup for saying, what should we do with those people? What can we do? What are we capable of? What can we offer to them as a set of services, because they don't know what they don't know. Once I've filled out a little bit of this and gotten a little bit of information on the locations, the position identifications, and I've filled out my user list. And if you don't know how to do those things and you're struggling with that, remember, come to tomorrow's Fundamentals of Penetration Testing with me, and that's where we spend most of our day. So once I've filled out this information a little bit, I come back to my client and I go, look at all that stuff over there. I know it's not in scope, but boy. And they might go, it might be to me, I go, these are the things that I found that aren't in scope. And they might go, wait a minute, that thing shouldn't be there. I want you to test that. I want you to change the scope of what you're doing. They'll go, okay. And usually what they do is they add to the scope, and from a financial standpoint, that's more money for me, which is a great thing. Let's see what else here. All right, so you document it all. You document all the possible accounts that you possibly can at that point. This is the artifact sheet 1. Now, that is the exact same artifact sheet that we had yesterday. Nothing's changed there. Remember, if you have this and this is new to you, make sure that you don't request it. What you want to do is you want to do a file, make a copy for yourself, adjust as you go along there. Okay. So before we go any further, does anybody have any other questions on day 1? You can populate them here, as somebody already did. If you don't want anybody to know that you wrote the question, go into the O'Reilly Q&A and type your questions there. I won't call you out. I won't say, HM said blah, 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 blah. I won't do any of that stuff. So I'll just give you 60 seconds there while I set up the mind maps for the day. We will be breaking in about 20 minutes. Excuse me. What did we learn on the first day? I just went over it in microcosm. That's exactly, you saw what we did on that first day. That's as close as I can get for this. So I just did my 5-minute recap from yesterday. Do you need to have a certain experience level before attending any of those conferences? I feel like it would be overly intimidating based on the knowledge gap. Come in, tell them that you're a noob, don't bring a laptop, turn off your phone, use pencil and paper. That's when I went to Black Hat EU, I didn't even bring, I mean, I had a load of equipment with me because I taught another class somewhere else, and then I came in. It was in Amsterdam. It was a pretty cool conference. And those people, they're always hacking each other, but they're doing it in a playful way. If you say, hey, look, I'm totally a newbie at this, they'll be nice to you. They're not mean. Let's see. Man, I still practice a lab yesterday. Will the website stay up for further training? That's a great question. So expsec.us, which I put into the attendee chat, is always up and running. What I may do when I look inside of there is I may clean it up a little bit. And if somebody comes in and really smacks the hell out of it, because you shouldn't be, but if they do, and it happens, then what I do is I restore the site to a previous version. So it's always running. I've made that a deal so that you can do all of the labs and everything that we talk about in class after our 16 hours together. You can do it on your own. You can send me questions. I like student questions. I have an external metric for me that my goal is with the O'Reilly students to get more than 500 emails per year. Last year, I just missed it. I was like, just about 4 emails shy of that. So I'm open to go ahead and answering your questions there. It's important that you get what you need out of this. How to leverage the full power of the recon and what are the tools to do that. The big tool there that I want to answer in this is it's called Maltego. So from a professional standpoint, it's not cheap. It's $1,000 a year for Maltego. I talked about it on the day. I just gave you a little hint about it in our discussion. I think from a reconnaissance standpoint, Maltego is the most powerful tool out there. It does everything for you. You have to learn how to understand transforms, which are very difficult, but also how to attach everything to it. And then to be able to work your way through the material that it gives you will eventually get you to pretty much everything that you need to know. I want to do a whole class on Maltego because just the setup alone takes 30 or 40 minutes, even to go ahead and just do the community edition. Okay, so link for the lab. Yeah, well, I'm going to show you that in just a second. Could someone, HTML files, GitHub, ask for the passwords, which ones? So when you go to GitHub, and that's what we'll talk about right now, and you're on the main page here, and you click the download code, you'll get one zip. That zip is the whole site and just drops it onto your machine. But inside of there, like for instance, we'll look at the 4-day, and you'll see that we have, let's see. You'll see these zips inside of the 2-day stuff right there. Where's that other piece? Oh, you only have those zips right there. So when you get to these zips right here, those are for the 2-day, then you have that password, and I will give you that password right here. And it looks like I need to update that list for the mind maps for the 4-day. So I'll put that in at the end of the day. But you don't need the mind maps in class. These are the 2-day classes, and this is the readings link HTML. Those don't have any passwords on them. Okay. So I promise I'll go ahead and put those other ones up there. I took them down because I have a new version of each one of those to give to you. Okay. So now let's look at the main page and talk about the lab for a second. Yeah, I got about 5 minutes. Okay. So the lab environment is changing radically. First off, in October, we will have a capture the flag contest. You'll see that coming up. It's way, way early for that, but just let you know that they have a capture the flag contest. And what you will be given is you'll be given an interface, and that's it. And then you'll have to go ahead and discover everything that's going on inside of that. There's a 12-minute video on this lab setup. So this is right at the GitHub. You can get to that in the resources section. That will be updated, but it works pretty well. So you have to have your AWS account. And what you need is the ability to use what's called Cloud Shell. If your region does not have Cloud Shell, watching the video, it shows you exactly how to do that. If it does not have Cloud Shell, just wait, like a week or so, and then O'Reilly and I have figured something out where Cloud Shell will be no longer necessary. Okay. No, O'Reilly, J-E, it's O'Reilly, not Dean. No, it'll be an O'Reilly event. I just talked to a bunch of people at O'Reilly, but it's not until October. Okay, so if you don't have Cloud Shell, this won't work for you. So I'll just tell you that right now. Figure out where your setup is, and then the hardest thing that you have to do is you have to create an SSH key pair in EC2. Again, watch the video. It shows you click by click how to actually do that. So now I put this little placeholder in here because this is going to be adjusted pretty quickly by me. When you open up the Cloud Shell, what you're doing is you're copying my public images that reside in AWS US East 1, which is called Virginia, Northern Virginia. You're copying to wherever you are. Once you've figured out how close you are, I don't want to know. Once you copy those images there, they change their names. And that's really the trick here. The cool thing is that this is, these are the individual commands, which is a real pain in the butt to do, but it helps you with tracking. Or what you can do is you can stitch all those commands together by using, inside of here, you will see it says ampersand, ampersand. And by using and, you stitch them all together, and then what it does is it copies them. Now, that can take anywhere from like 2 minutes. Today, I did it for Ohio just to practice it for here, and it took 30 seconds. And I have no idea why it only took 30 seconds, but it took 30 seconds to copy 28 gigs of information over there. So something must have happened. You need to wait at least 15 minutes after you've done this copy command to get yourself ready. Then this is the deployment guide. Once those images are there, then we use this thing called a YAML file in what's called CloudFormation. Cloud Shell is different than CloudFormation. In CloudFormation, we have a script that executes against those images that you've copied there, and then it delivers the entire environment for you. Thank you very much, TR. Thank you very much. So they're getting even slimmer and slimmer and slimmer. But here's what's cool about this. Once you do this, you now have these images. This is your lab. You never have to talk to me again. I hope you will, but you never have to talk to me again. You just have to fill in the parameters, and then you're ready to go. What's gotten very clean about this is what we just did in the update was you don't have to configure each one of the logins for each one of the instances. They are there. They are present. You don't have to figure out how, you don't have to know anything about AWS except for to follow my commands. And you will have what's called a guacamole instance, which is really beautiful. How do you get in? You go into your console, and I'm going to show you exactly with mine right now. You go into your console, and what you will see when you've done it correctly is you will see whatever you named your stuff, it'll bolt my name onto the end, and you're looking for the one that's called guac right there. I have other stuff in mine. You scroll out, and you look for this public IP address, and there's the public IP address. That's the only public IP address you need, as long as everything is running just fine. As long as you don't break your images, fine. You take that and you key that in, and it pops up like this. It should not give you the warning message, you know, like you don't have this signature or this SSL certificate, blah, 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 blah. You know, your browser shouldn't throw up on you. And that's the difference between if you did it yesterday versus today. Yesterday, it would go, your browser doesn't like this place. Do you want to advance? Now what it'll do is it'll just say expanding security. And all you have to key in is Kaylee with a password of Kaylee. This instance, I'm not going to save it. This instance is only accessible by you because you put your IP address in there, and it created a very narrow scope of availability. It says for your IP address, you can use this Kaylee instance. I can't use it. Nobody else can use it. It's locked down. All of the machines that are inside of here, they don't have public access to the internet except for the actual Kaylee instance. It has the ability to go out and pull down new patches and new things. So you can do that. But the two victims that are sitting in there that are very, very vulnerable, as long as you don't mess with the, as long as you don't mess with any of the firewall rules in there, they are in this little environment and you can beat the hell out of them and everything is good. Now you'll notice that this page is black. And it just started populating. Like if you look up in the corner there, and now the desktop pops up. Only the first time, because it's trying to pull all this stuff in, only the first time does this take time. Once you're here, you're inside of the location. And then this is what I wanted to show you. I'm going to open up my terminal here. I'm going to type in if config. It's going to say, Dean, you've got a 10.4 IP address. Those are internal non-addressable IP addresses. If you looked at any of the other stuff that I talked about on here, you will see that you have a Linux victim that is 1010, a Windows victim that is 1021. Those are the only two. So I should be able to ping 1010 and 1021. ping with a count of 1, 10.0.0.10, and it responds. We had a little bit of a weirdness there. And now what I'm going to do is I'm going to ping with a count of, it's chipped off the edge bit. Okay, let's try this again. Oh, we got 2 screens there. Let's see, that's going to break stuff. Okay. Let's try it again. And so now what I'm going to do is I'm going to ping 21. Ping with a count of 1, 10.21. And there it responded to me. Now you'll notice, by the way, a little trick for you if you're old school, if you've got zeros in the middle, you can skip the zeros. You can type in ping.21 and not put the .0.0 in there, and it'll still work for you. That's stuff I learned old school from Mike Moose and all this other stuff that's out there. So both my hosts are up, and now I know a little bit about them. Normally what you would be doing is you'd be doing a scan for that. This machine is ready to go. It's ready to attack those machines. When you're finished, at the end of the day, I can't stress this enough, make sure that you go back into your running machines. So right now what I will do is I will say, these are all running. You can see each one of them is running. What I will do is I will select all of those machines, and I will choose instant state, and I will say stop. If you do that, your charges for holding these machines, because of storage, is about $1 a month. If you don't turn them off, it's about $1 an hour. So turn them off. There you go. Okay, that's all the question. Let's see. AD said, Cloud Shell shows availability for US East 1 and 2, but I can never get it to load. I keep getting unable to start the environment. I have tried all 4 regions. Okay, so AD, it sounds like you're somewhere in the United States. If you own the account, then you should be allowed to go ahead and instantiate Cloud Shell. If you're getting it from somebody else, like it's a non-root console that you've been given from your country, from your company, you may not have Cloud Shell access. They may say, sorry, you can't do that. So let's see. A lot of things you realize business utilizes for a lot of things. Okay. Yeah, there are 12 free months at AWS, but the machines that we're using, if you look here, T3 large, T3 small, T2 large, T2 large are not in the free tier. You will be charged. So the machines, I tried to do them like for no cost under the free level. And what happened was the labs went so slow that you'd like click a scan and you'd go get a sandwich. Okay. I'm currently looking at Maltego Pro. WP, I don't know. There is a subscription at $1,000 a year. I'm pretty sure about that. There's just a Maltego and then a Maltego Pro. Maybe you're using the Pro version. They're looking at the Pro version. Okay. Yeah, there you go. Somebody else helped you out there. Okay. On the page, Maltego. Okay. Okay, so everybody's good there. Can I run it in another region outside the United States? Yes, you can. You just have to have Cloud Shell. Remember, we talk about that right here. It says, this was an early student that did this with me. They said, this was K, said Cloud Shell is only available in some regions. And so what you have to do is you have to click that Cloud Shell link and it'll tell you. Yeah, now there are a few people, and they sent me emails, and you can still do this. There are a few people who said, I don't want to use AWS, or I want to use something else, but I like your images and I want to use them. If that is you, you must send me an email vmlt.com. Do not give me your email in class. Send me an email and say, I need the images because that's how I want to do it. I want to download them locally for VirtualBox. I have them. What I will tell you is you will only need the 2 instances from the 2 victims. You'll build your own Kaylee, which is much faster than downloading my 28 gig version of it. You'll build your own Kaylee, and you must do your own networking. The networking doesn't hold when you pull those machines down and push them into new virtualized environments. So that's why I give you, at the bottom, that's why I give you the IP addresses of them. So if you have to set this stuff yourself, you must make sure that your 2 instances, if you want to follow my labs, are 1010 and 1021. All right. I think that gets everything. That brings us right up to the first break. When we come back, we will discuss enumeration. We'll get into this mind map here. We'll talk about it, and I want your questions for enumeration. I'm going to do very quick highlights on enumeration, focus in on 2 areas, give you 3 examples of each, and then it's like question time for you. For those who didn't get a chance to watch that video, hang out with the questions, look at other people's questions and see what they're trying to understand there. And then today after class, watch the enumeration video again, send me email questions, and I'm happy to answer them for you. So with that, we're going to take our first break. I'm going to ask Heidi to put the break slide up for us. It's going to count down for 5 minutes, and I'll see you in 5 minutes. Have a nice break. Welcome back from your break. I wanted to talk to you about your setup. And I made a couple of mistakes when I was doing my setup for displaying it to you. Always use the little bit of desktop. You can see if you look down here that it's just this little tiny bit of the red desktop that's popping up for me. Use a little bit of red desktop to let you know where your windows end, because what I had was I couldn't see my command line because it was off the window. The cool thing is if you resize this window and you make it large for yourself on your side after I'm gone, if you click back in your browser and then say refresh or reconnect, you'll get a screen redraw that will take advantage of your entire real estate. So you won't be locked into like an HD monitor or that kind of thing. I know that when I do it on my 4K monitor, I can stretch it out pretty big and get big command lines. But then the other thing that you want to do is once you're ready to do your labs, you want to have a command line up on one side. You want to have your browser up on the other side. And you'll notice that inside of the browser, and I know it's a kind of a squint-a-thon there. Right now you're seeing EXPSEC, but you'll see the link for the GitHub site is right there built in. So then that brings you into just my main GitHub repository. And you can go to CEH repository, and I'll get to that. And so I'm looking for my CEH. There's my CEH bootcamp repository. And then for all of your labs, remember to go up to the top where it says wiki. And then when you're looking at your wiki, you want to look for lab 4-day. And I'm going to give you this link in the attendee chat. And here's the thing, if you're doing your labs and you need to copy command lines because you're not that strong in this, you can take this command right here. Like for instance, it says sudo I. There's a little copy button there. I click that and I can paste. The trick to this is your browser with your lab instructions must be inside Kali. If you try to copy and paste from your desktop into this guacamole instance that's there, it won't work. So that's why I set that up for you there. Okay. So that's labs, that's for later. We're going to come back over here and we're going to, let's see, I took care of all that. We talked about scanning and the lab for scanning. So I'm just going to point to the lab for scanning. When you do scanning, what I told you yesterday was that you want to make that scan, you want to make it easy and elegant. And I said to export your results to like an XML file so that you could use it for other tools. And that's what you want, is you want portability in those results. If you went straight to Nmap and output, it comes out to a terminal, and that's not very good. But what I did with this lab right here for scanning was I said, instead of doing it in Nmap and then bringing it over later on into Metasploit, what I said was use the Metasploit console and call Nmap from within it. And that's exactly what this lab does right here. It does an Nmap scan inside of Metasploit. That's it. That's all it does. It's not very fancy. I'm going to come back to that and show you that in just a little bit, but I want to get into our discussion today. The weirdness that happens here every once in a while, it's a little tough to read on my machine because it's red on black. My prompt changed at that point, but my text is still white. So I'm going to copy this one. And that's setting up my MSF console. And I'll leave that go. Okay, I don't see any other questions. Okay, so for enumeration, a lot of times people think that the scan with Nmap is enumeration. It is, because the word enumeration means to list from top to bottom on whatever database that you're in. But enumeration is kind of a deeper scanning. It goes, okay, now that I've found this open port, what service is running at that port? And I'm not saying let's abuse that service. Let's just interact with that service. So in enumeration, we have an open port that's listening. That's the first requirement. We create an active connection with the system. So that means that people will know that we are there. And now all we do is we perform directed queries. That allows us to collect all the data, whatever is available to us at that moment in time. If I stepped onto your network time protocol server, your NTP server, and I said, what time is it? It would say, here's the time according to the atomic clock. It's a reasonable service. It's a reasonable query, and it would return that to me. Suppose your time formatting is in universal time coordinates, universal coordinate time, UCT or UTC, and it's in 24-hour time, and I'm in Central America. Well, it's going to be different. So I can say, query the time in Central America time, and it would convert that and give that back to me. Some NTP servers will say, no, we're not going to do that. Okay, so now how are we going to use this? Well, we're going to use this for further enumeration. Again, remember, it's a cycle. And direct knowledge of information or actual vulnerabilities. Now, this is the winner in all of this stuff for those who didn't come. So, I mean, for those who watched the video, hang out with us just for a second. This is where you get into your first real controls, which are authentication and encryption. And all the services out there have authentication. It depends on what kind is set up and where it is set up. But there is authentication, even if it's like your default web server. Some services have encryption. It's either going to be built in or bolted on. And then here's the key. This is what we get paid for. So what's that authentication and that encryption look like? That's all based upon how good the protocol is, because some protocols, especially newer protocols, kind of suck. They don't do it very well. We just got this running. Now we'll worry about securing it. The vendor implementation. Some vendors are really good at implementations, and some vendors are really bad at implementations. I have a lot of Microsoft certifications. If you look at my mug somewhere on there, what you'll see is that I have a lot of Microsoft certifications from all the way back in the 2000s. And what I came to discover about Microsoft was the first version of a product, not that good. The second version of the product, not that good. The third version, pretty good. So anytime Microsoft was to put up a new version of a new product that they wanted me to learn so that I could go ahead and then support that for my customers, I knew that the vendor implementation was going to suck for the first two versions of it, but eventually they would get all the kinks worked out and it would be just fine. From a security standpoint, that no longer is true with Microsoft. They've changed their tactics because it's 25 years later. But here's the key. The degree of rigor of authentication and encryption varies by user setup. That is what we are testing. That is what we are focused on, hands down. If there is authentication, authentication means username and password. If you don't have anything, if you did no reconnaissance, if you suck at OS, open source intelligence, discovery, and reconnaissance, if you didn't do any of the stuff that we talked about yesterday, and you really suck at what that is, or you just didn't do it, then you use brute forcing across accounts. So you need a brute forcing tool. Questions on that before we go on? That's kind of, if you forgot everything else, this is kind of the key to it, and then we can go over and we can look at all the implementations. For the people who watch the video, questions, only for those people. So everybody else hang out for a second. Questions on this section. If you're good, throw me an exclamation point. If you have a question but you don't know what it is, throw me a question mark. Y'all are so quiet. Okay, good. There, good. So making sure. Okay, now here's the cool thing. If you're struggling, for those people who are throwing question marks, what we're going to do is we're going to break this down. We're going to talk about the methodology just for a second, and then we're going to talk about terms and protocols. For methodology, we are past the reconnaissance. We're doing a scan, and part of the scan is enumeration to map open potential vulnerabilities of just saying, hi, service, tell me what you're willing to tell me based upon no authentication. Oh, you need me to give you a username and password? Let's try admin with a password, or all the other possible combinations. This will lead to exploiting, but that's not what we're doing right here. This phase is the richest. Now, you see the little blue eye? That means you have to know your ports. For your exam, commit to each one of the protocols that I've listed here, and at least its port number for every single one of them. Now, I'm not going to go over those because that would be insanity, but there are a lot of them. You should know each one of them. I'm not covering them here. That's the basics of security and networking. So all the way down to the last one on my list, because they were in alphabetical order, is X11, which is on 6000 by default, but that's only a local one. Now, what you'll see next is I talk about the protocols and the techniques. What is the protocol? What are the rules of operation when doing enumeration? So you'll see with each one of these, what I've done is I've given you a basic understanding of it, and then I actually do like details of each one. So this is the general process is what are we attacking? So we're attacking some form of vendor software. It could be operating system specific. I could give you a count of like how many there are. It's important to know how many different versions and how many different vendors there are that do this particular product. If you've ever gone into Gartner has this magic quadrant and they show you all of the different vendors in a particular space and all those dots there. Lots and lots of dots, doesn't matter where they are. Lots and lots of dots means that it's a crowded market. That means that when I, as a security person, come in and I use this vendor's version of this and I go on to the next location, to the next job, I'm going to use a different vendor's version of that particular product that solves that problem. And if there's lots and lots of them, then end users who are administrators at a certain point, this is about user setup, will go to the lowest common denominator. I also sometimes, a product may have a weird name. Okay, so then once we know what the software is, then we figure out what its function is, what data we get from it. Is this useful to us? When is this useful to us in our methodology? And if it has any kind of special ability, then we talk about that there. Let's go over to generally for a second, and we'll come back and I'll explain the details of that. Generally, here is your techniques and processes and on all of this, because I didn't name off every single port and every single different piece of software because, you know, that would take forever. I did give you a list of the common ports that you care about. So here's your general tactic for this. You've done an Nmap scan, and that Nmap scan says the port is open. If it's not open, don't waste your time. And that's not blocked by a firewall. That means a service is running. How does it transmit its data? Is it in clear text? That means that it's sniffable. That means that we could listen on there. Most of the time it's encrypted, so just accept that as the fact. Okay, what kind of authentication are they using? That breaks down into 5 major kinds: none, default. In the device default, it breaks down further. Does it have lockout, and are we using 2-factor authentication? For device default, what you want to do is you want to go to a place where you can find the default passwords. Now, I want to do this with you. Take a second here. I'm going to give you this link. Say a little prayer for me for my copy and paste buffer. Oh, that's not the right one. Let's see. I don't think I can pull that up. Hang on one second. Ugh. That was messy. Sorry about that, folks. Okay, so here's the link, the main link. I'd like you to add on to the end of that link in lowercase passwords.htm. And that'll get you to this main passwords page. Below that, thanks. What you'll see is there's default passwords alpha. Now I'm going to click on this because I want to show you this link. And what that does is that changes into passwords, just like RP did. Notice that if you look up in there and you squint a little bit, it's a capital A. And this is a weirdness in this site. So if we type in passwords plural with a capital A.htm, you can click on that link. But what I'd like you to do, once that's populated in your browser, then I want you to type in passwords, and instead of an uppercase C, do a lowercase c, which is what I'm going to do right now. I'm going to type in a lowercase c here, because I don't want to go click through it. And you go, not found. Case counts on this machine. This kind of thing where we're playing around with the URL line and typing in our own C there, that is the hacking mentality. An end user would go through and they would start doing search for this stuff. We didn't do that. We went ahead and messed with the URL line. You should always be thinking about how you're going to mess with the URL line. I know that it's a fake example here, but you get the idea. Now, if you were to go into an organization and they were just setting up their new Cisco, let's see, we'll call it wireless access points. They have, for their wireless access points, we're going to find them, and they're called the wireless system controller. And you say, okay, well, this is a brand new one today, so that's going to be greater than 3.2. The default password is, or the default login is root, not admin. And the default password is public. And you can look that up for any one of the devices, any one of the versions, and see that that's set up. Now, immediately upon logging in for most secure devices, it will say your default password is accessible at this point. Please change your password, right? So now I want to ask you a question. If the default for a new one is, yeah, right, you got it, AD. If the default system username root password public is there and the systems have already been set up, can you think of a way where we could make it go back to the default? Can you think of a way where we could make it go back to the default? What do you think? Type it into the attendee chat. I'm going to need something to make it return to the default. Anybody got anything? Yeah, how do you do the factory reset? There it is. I'm good. AD had it. You can use a paper clip. That's the norm. And you can find a paper clip in almost any office. You can actually unscrew a pen top. And in a lot of cases, one of the particular pieces of the pen, this is a 4 combination pen. Sometimes this will fit inside of there. Sometimes you can do it with a pencil or a pin. But that's your factory reset right there. So if you have, and remember, normally the factory reset isn't it's a recessed button. It's not a poking out button that you can just hit with your finger because they don't want you to hit it by mistake. But that means if you've got physical access to that device, then you can go in and reset it. You only have to have really good aim with a paper clip in one of these places for 10 seconds. That's it. Some people never reset. Yeah, if you've got the dip switches, yeah, some of them will actually have those on the back. Those are, MC, if you've seen anything with a set of dip switches on it lately, I'd really like to know what that is. By the way, for those who don't know what dip switches are, it is it's like a firmware configuration defaults to send to the actual underlying motherboard in a lot of cases. Usually today what we use like jumper pins and things like that, even if they still have them. So your idea is that you want to get to a default password, and that's the simplest, most elegant way to do that. But there are a whole list of default passwords out there. By the way, Shodan is really good at this. You go, okay, well, wait a minute. I don't have a default username and password, and I have to be careful with the system because they're listening to what I'm doing. Well, then this goes back to your Recon and your OSINT, and you build that disposable list of accounts. See if they match the domain login from your other Recon and scanning that's out there. Now, I know what you're saying. You're saying, well, Dean, I tried to do the lockout. If the lockout's off, then you start brute forcing and you start looking for service accounts. That's what you want to go. But what happens if lockout is on? Good. They put security controls in place. And that means that what you're going to do is you're going to use those accounts that you have, you're going to force them to lock out, and you're going to record that information. Vendor lockout on this particular service is set at a threshold of X. For this particular service, it's set at Y. What does this mean at the end of the report? Maybe you say something like, for consistency's sake, make sure that your lockout threshold for all of your accounts is set to a higher level of or a lower level of. So that's lockout. And it's okay if you get locked out. You just say, I used up these accounts. That means that in your Recon, you should have collected as much as you could. What happens if you encounter two-factor authentication? This is Dean's prescription if you are not doing a two-factor authentication test. That's a separate test. And it's run away. You say, I've encountered two-factor authentication. When you were doing the website yesterday, if you got to a place where you typed in user and you got the right password, some social engineering would have given you the right password to accounts that had two-factor authentication in place. A very high-level user will give away their password, but because the two-factor authentication is in place, it doesn't matter because you don't have the device that does that particular thing. The only thing we have to do next is pass a proper query. And I know what you're saying. You're saying, oh my God, Dean, I don't know how to do SQL queries. I don't know how to do LDAP queries. I don't remember what the syntax is for FTP. You don't have to. Kaylee.org/tools, and then type in that protocol, and it'll go, here's 15 tools to use, and here's how you install them, and here's how you use them. You win. The end. It's not any fancier than that. Okay. So I'm going to use 3 examples for protocols and techniques. But before I do, I want to, for the people who watch the videos beforehand, what are your questions? Just for those people who watched beforehand. If you've got no questions and you watched it beforehand, throw me an exclamation point. If you have questions and you don't know how to form them, throw me a question mark. For everybody else, hang out just for a second here. And we are going to go to a break after we talk about protocols and techniques and 3 examples of each. I don't go over all of them. This is a 47 minutes discussion. And what I'll say is watch the video on that part. If you're struggling, I'm going to give you examples. If you have a good formulated question, I'm here for you. Okay, so let's talk about 3 examples of protocols. What are we attacking? Is it a Windows machine? Well, then it's probably running some form of server message block. On Windows currently, Metasploit has a way to attack Windows. That's good news for us because for a while, the SMB relay didn't work. Okay, but that's a separate aside for a second. What does it do? Well, it allows us internally to have endpoint mappers, net bias name service. The one that we care about is the bottom one. Is port 445 server message block protocol open? If it is, that means that file sharing is available to the end user. We don't normally run this on the servers themselves in some cases because we'll use some sort of like NetApp or something like that. But if it's running on a local workstation, that means that a client has control over files and permissions locally. What would you guess that an end user will set their permissions to for files if they're trying to share them with somebody on the network? What would be the permissions that they would set? Least restrictive or most restrictive? What do you think? Okay, so what do you get out of this? For those 2 ports that are open, we can find out all this juicy information. Work groups, system times, all those kinds of things. Yeah, and exactly, MC. It would be full control, everyone. And NS, I will tell you that I would love it to be least privilege. In military operations, it's least privilege. In normal commercial entities, it's most privilege. It's full control, everyone. Here, let me go ahead and show them everything because they don't know how to set permissions. How is this data useful to us? Well, contents of an open share is a biggie, but this is the key. The list of computers to further identify systems or vulnerabilities. That's the key there. It tells us if we couldn't see anything, but we saw this one system and it had collected up some shares here or some host names, then we can start looking at those hosts right there. There you go, AD. Okay. How do I know which enumeration techniques are used and what cause harm to the target systems for testing purposes? Okay, so TR, let's be really clear. None of this is causing harm. All we did was query that service and say, what do you got for me? And it may be in your scope that they said you cannot brute force. Okay, well then, did I do reconnaissance, capture accounts, and then query with the authentication? Was the authentication turned on? Was it turned off? Was it default? In any of those cases, you're just saying, here's a username and password. There's no harm, no foul, no corruption done to the machine at that point. It exists. None of this is causing harm. That's the beauty of enumeration. Because if you get locked out, you get locked out. If you keep on trying to do usernames and passwords and it keeps on rejecting them, then no harm, no foul. You get in, it gives you data. This is what was available to me. What kind of data does it give you? Then that's really what we're talking about right here. Okay, so you got that idea for that first one. Let's talk about my two favorites, SNMP and LDAP. When you look up this software, it's typically called network management software. Now, here's the thing. Last count, there was 140 vendors. That means that when I learned how to do SNMP here and I moved to the next job and the next job and the next job, I am going to use my common knowledge of all of them. I'm typically, as a low-level administrator, not going to crank up the security because it's going to break things and I'm going to get yelled at. I'm just going to go to the least common denominator of all of those things. What does it allow us to do? At first, if it's 161 is open, that allows us to send request and response messages. You have a management workstation in SNMP that you can impersonate, maybe, and you can say to the device, like the wireless LAN controller, how are you? And it reports back all of this stuff. Do you have to know how ODI, OID, and identifiers work? No. Do you have to know what the MIBs are? No. There's a tool that does this for you. I don't know what the MIBs are, and I've recorded long conversations about MIBs for Cisco internal MIB identifiers over and over and over again, like 20, 30 hours of that stuff. Let's see, question. Are there any industry best practices or frameworks for conducting thorough enumeration pen testing? Yes, yesterday we talked about the pen testing platform. We discussed that. Next port in SNMP is UDP trap. And in this case, this is an alert from an agent. We tune that device to say, we pre-configure it to say when it's having problems, it goes, I'm in trouble. Now we can sit there and we haven't done anything. We're sitting there and we're listening and we can hear this 162 traffic coming back. I've been on networks where it says there's 162 network traffic and I can't read any of it. But what it tells me is these devices are in trouble. That IP address of that particular device, when it's sending back that information, is in trouble. I don't know what kind of trouble, but I know it's running SNMP and I'm going after it next. That's really what's going on there. What do we get from this? Well, this all depends upon the host and what it's configured for, but generally we can query the settings on them, and in some cases we can update the settings on them. Oh, your intermediate router inside of your network is supposed to be using that default gateway for this network here. I'm now your default gateway. And then what I do is I take all that information that's flowing to me and I pass it through me back out to that default gateway if I've got access to that area. On computers, I can know what's going on with them. Microsoft machines are famously, if they're running SNMP, they tell me lots and lots of great information. Even, is Windows still running? That's really old school. On routers and switches, here's where we win. Configuration and statistics, like default gateway, having it come and talk to me. How about this for printers? Configuration and statistics. Today's printers have storage capability on them, long-term storage, and me as an attacker, when I want to get my information off of those machines inside of that network, I need a place to put it. I don't pull it out right away. It's called loot, and I put it on a printer. I put it on a print service. A lot of print services today will allow you to store gigs and gigs of data. It may be that you have physical access to printers and nothing else in the environment. Everything else is locked away in a closet. I have, in my environments, when I worked for when I did one test, I stored all my loot on a huge HP printer, and then I came in with my fake HP shirt on that said HP service. And I came in and I said, I have to go service that printer. I just need to swap out the drives. I don't have my work order for me. I missed it. I lost it, blah, blah, blah. And they said, we'll escort you over to the printer. They escorted me over to the printer. I swapped out the 2 drives. I plugged the new drive in, and I have all my loot with me, and I walked out the door. So we can store it there, and we may not be able to get it off that network, but we may be able to social engineer somebody into letting us have access. Or I could say, look, if you don't want me to come in, just pull this one out and plug this one out, and then we're done. And they may let you do that. They won't let you do it in banks, by the way. Okay, what good is this stuff? Well, if I can brute force one device, SNMP, and it's got usernames and passwords on it, here's the good news. If I can brute force one, then I have the credentials for all of them, because the standard least common denominator administrative configuration is to make sure that all devices have the same, they're not really called usernames and passwords, but the same public and encryption that's going on with them. So once I find one, and I'll go pick on the little device that doesn't have lockout on it, or isn't really paid attention to, like the thermostat or something like that they have in there. Or really good ones to attack are, have you ever seen the really cool light controllers that are in really fancy conference rooms? They usually have an IP address on them. They usually are running SNMP. I've attacked light controllers before, figured out what the username and password is for SNMP for them, and then I can use that against all of the other ones in the area. You will now know all the devices under management at a minimum. This builds a beautiful network map. If you're really good and they're really stupid, you can reconfigure the devices. This will support man-in-the-middle attacks. Sorry, ladies. Okay, got that one. Last one is LDAP that I want to talk about. Let's see. During a pen test. Let's see. Are there industry best practices, frameworks for conducting thorough enumeration pen tests? This, oh, by the way, I want to say this to you, TR. This setup that you see here, this discussion that I've talked about, enumeration, nobody talks about it. I mean, I've looked for it, so that's why I did it. Okay, LDAP, v3. When we look at LDAP out there, the vendors, we've got a bunch of cross-platform stuff out there. Linux, Apple, and Windows has got 5 different versions of it out there. Now, they're all for their same operating systems, and some of the operating systems don't use it anymore because we don't run those operating systems. What does it do? It's directory services, and it usually is a central repository for usernames and passwords on Microsoft machines. When we're looking for our ports, we have 2 different ports that we're interested in here. A lot of times when people run into 636 LDAP over TLS, they go, oh, I can't do anything. You can. What do you get from this? First, you get what's called a distinguished name. It's a unique identifier, and it looks like a bunch of slashes or a file directory. These are called containers. It's all set up in the LDIF format, well, in the LDAP data interchange format, but you don't have to know anything about that. You have to know that it exists. You have to have seen it once, and then you can pick up the tool from Kaylee and use it to go ahead and deal with this. What is this good for? User accounts and passwords, very late stage user accounts and passwords. Services in use that are available to us. Kerberos, DNS, and databases are all a function of Microsoft's LDAP, and it will allow us to do reconnaissance. Generally, you're not allowed to look at a lot of stuff inside of LDAP, but you're always allowed to look at the phone company directory, email, phone, department, and role. In Microsoft, it is everything. So now I wanted to zoom into this for just a second here, and I want you to take a look at this. This is the General tab. Notice if you look up above, you'll see all the different tabs that are available to you. The General tab gives you all sorts of juicy information. And if we look down here, we see telephone number, email, and web page. You can query this in a lot of cases. Or here's the beautiful thing. Let's say that the organization, they're not using an auto attendant, but they actually have a physical receptionist that picks up the phone and says, how may I direct your call? That's what you're looking for. You don't want the auto attendant. How may I direct your call? And I go, my name is John Smith. I work for the company, and I noticed that my telephone number is wrong. can you change my extension right now from my cell phone to this because I lost my phone and now I need it to go ahead and be this. And I don't know who John Smith is, but that person typically, who is the reception person, has the ability to change some of these fields inside of here. They have the ability to query any of these names in here. I can't remember who I'm supposed to call at this point, and I really need to talk to somebody who is in accounting. I've lost all the accounting information at this point. Oh, let me look that up for you. Let me transfer you to that person. If the auto attendant is on, it's a little bit more difficult to do. But this is just the main page. Remember, we can slice off pieces of this in Active Directory's LDAP, and we can say, you're in charge of that. They're in charge of remote access. They're in charge of password replication or attribute editors or profile or whatever it is. Any one of these tabs can be handed out to any one of these people. It's our job to figure out who's in charge of what. We would have figured that out by looking at, previously yesterday, by looking at the people who were in charge of, like, the administrative manager or human resources that would have this kind of data for us. What do we get out of this? At first, we probably don't get a lot. Maybe we get a couple of usernames and passwords out of this, but I doubt that. But the ability to add and change accounts later on, to create new accounts after we've done inappropriate activity through buffer overflows later on, we can come back into this. And now that we know that LDAP is there and that we need an administrative account to create accounts, we can come back in and add and change accounts. Also, if you're familiar with Microsoft's implementation, they have configuration on a container by container basis. Usually your dev department has less restrictive Active Directory policy applied to those physical machines that are there. And so that is less, less secure, and therefore we can go after it. When it goes into production, it gets moved out. That machine gets moved into another container, and now we have a really heavy duty policy on that doesn't allow us to get in. Okay. For this, we're going to take a break in just a second here. For this, when we look at the outcomes, I've given you 3 examples. With the exception of VoIP, I put that in here for full disclosure, but with the exception of VoIP, you need to know what is important about those protocols and the constructs, that the data that is available to you in basic enumeration. But the next thing that we need to do after our break is figure out how to specifically attack some of these protocols. That's what we're going to do after the break. So I want you to run away and go play. Heidi's going to help us out, and she's going to put a 5-minute break slide up for us when she gets a chance. Let's see, AD, that should be an IT request. Phone changes. Oh, AD, I agree with you. It should be phone changes. So I can't hear Heidi right now if she's talking to me. Any other questions before we take a break? Heidi's going to jump in and give us actually, I'm just going to put up a pause here for 5 minutes. And so I'm going to put into the chat a 5-minute break. Keep your own time. Yeah, it's a lot going on there. Keep your own timing just for this. It's according to this, I'm about 4 minutes from the bottom of this hour. So I'll see you in 5 minutes, and run away and go play. I'm going to be mute for the break. Okay, everybody should be filtering back in. No, we were mute for a break, BT. We're coming back from the break. They've got about 30 more seconds before they come back in. Should have a little break music going on. Something to let you know that they're, you know, like the Jeopardy music or something like that. Because we have to be careful about copyright kind of stuff. I actually just bought an analog synthesizer. I'm really excited to get it. I cannot play music. I do not have a solid note inside of my head, but I can push buttons on a sequencer, and so I think I'm going to make some music for our break stuff. We'll see. We'll see if it works out. Okay, questions, problems, issues on what we've done so far. So now let's talk technique. That's really what we're into. Now, this is a specific set of techniques. This is not the only set of techniques. And if you're looking for a perfect set of techniques, there isn't one. If you're looking for the perfect tool, there isn't one. Well, Metasploit maybe. But if you're looking for the perfect tool, remember sometimes this is based upon what you have available to you. It's called living off the land. You might be able to get onto a machine and control that machine, but you might not be able to install any software. So you have to learn how to do ping with a count. And you have to figure out that, oh, I want to do a ping count of 1 for all these different IP addresses. I might have to write myself a little kind of script to go ahead and identify what targets are on that kind of thing. You know, am I allowed to use ping? Am I allowed to use telnet? Am I allowed to use the command line? And sometimes you don't even get that. But you have access to the machine. It's like, okay, now what do I do? So how do we do this? Now, a NetBIOS, I will tell you that you're going to get a little bit here. In most environments, they've locked this down with the pre-patching environment. You look for the ports that are open. And for the enumeration, there really are there are many ways to do this, but the simplest way is what's called a null session. And that is a command line structure that will work when you're on that local machine, on that local network. And it's just basically net use, the IP address, and there is always what's called the hidden shares. One of those is the inter-process communication hidden share, IPC $. But your Windows machine has got $, $, or whatever those root drives are. And so you can attach to each one of them. You'll see that at first what I do is I have sets of double quotes, and that just basically says, this is the password that I'm passing. Yeah, okay, we'll get to that tool. I promise, TR, yeah. And then the username, now here what I did was null. But if you've got credentials from your discovery and recon, you can put the usernames in there and get, you know, like not have the password, or say you got a username and password for that user, you can populate that in the net use and that'll work just fine. But this one's saying, I don't have any of that stuff. What can I do? The other built-in command that you might be interested in is called netview. And that's just straight up IP address at that point. No resolution, no nothing. The resolution hasn't kicked off. Now, you could use NBT scan. I like NBT scan, but one of the other ones that you might be interested in is SMB client. And SMB client is something that's inside of most, I think it's the default Kali instance, depending on how you set it up. But SMB client list, you know, that's it. That's -L. List this server, list this share. The server would be the IP address that you know because you've scanned for the IP address. The share would be your defaults, your $, your $D$, those kinds of things. Ah, very good. TR came up with that Nmap has a built-in Nmap scripting engine, NSE, has a script for enumerating the shares that way. Yes, you could do that right there, and that would be very elegant to use. So they're all over the place. This is not just one-offs. This is just suggestions. Let's say that they really lock this down. Sometimes all you can get is 2 files because the SMB protocol is running. Sometimes you can just retrieve what's called the SMBconf file, or at a very, very basic minimum, you could capture the LM hosts file. This is like the DNS host file, but it's the LM, which is the LAN manager host file. Every once in a while, to solve particular networking problems, old school Windows administrators would populate the LM host file with certain entries inside of it. So you wouldn't be able to get to anything else, but these LM host files are there from upgrade after upgrade after upgrade, and they're sitting on that server, and there's no real reason for them there, but they tell you some good information. So I'll take it. Sometimes it's just, you know, whatever the replication is for the directory services. Okay, now the one that's a little bit more involved is SNMP. For SNMP, there are 3 versions. For version 1 and version 2, there are no usernames. It's not really a password, but they call it a community string. It's not even, once you know that password, the default community strings are public and private. But pretty much everybody's gone to SNMP v3. Oh, wait a minute. Remember the administrator that went from this job to that job to that job to that job? And they don't know about SNMP v3. They only know about how to make SNMP v1 or v2 work. So what they do is they rip away all of the support for SNMP v3. But what's there? Now, unfortunately, they don't call it, the privilege is really encryption. The authentication is using an MD5 password encryption or a SHA password. So instead of encryption, they use privilege. I don't know why. SNMP, the MIB people mess this thing up. Okay, so the default for backward compatibility is no authentication and privacy. Remember that administrator that went to the 4th job over here? They're going to strip it down, and they're going to say, turn off that authentication and that privacy and go back to public and private. That's what they're going to do. Seen it. They'll turn them off, but no encryption. So that's authentication without privacy. The privacy is encryption. That means that they'll do authentication, but the streams that are going across are unencrypted, and you can look at all the text going by. And then there's cranking it up where you have both of them. You go, Dean, a good security person would definitely turn on authentication and encryption on every single one of these things. They would do that across all those different devices. Remember what this device traditionally is. It's a router, it's a switch, it's a printer. For routers and switches, if we look at the device itself, its main function is to route and switch. It has a very little brain and very little memory. And therefore, if we decide that we want this thing to report to us in some sort of management console, we do not want to consume the CPU that's on this device. Think of this brain in these things as less than a Raspberry Pi, less than your watch has in it today. And it's got a lot of routing to do, and it's got to do that very, very quickly. So it's optimized for that. So sometimes what they'll say is, look, that's clogging up this router. So we're just going to go ahead and strip it down. We want it to report, but we're going to turn off the encryption. We're going to de-optimize the authentication from SHA to MD5. SNMP GET will also help you a lot. Yes, I like that, TR. So you can do the authentication, which is MD5 and SHA. We all know that MD5 has been deprecated to this point. We don't use it as much, but these devices will use it. The encryption methodologies are going to be either CBC-DES or Cipher Feedback AES-128. It's not AES-256 because, again, remember, that requires typically a separate chip on the motherboard that does the encryption and decryption that takes away from its main purpose. The first thing that you do for this is you check for the default password list for each vendor, and if it's not there, you brute force it. There is, to my knowledge, no lockout against these. The way that we protect, if you're from a defender standpoint, the way that we protect SNMP v3 from brute forcing is we turn up the listening mechanism, some sort of intrusion detection, intrusion prevention system, and we listen for brute force that's happening. Maybe we have time for that. Maybe we can turn that on. From an attacker standpoint, I go after these and brute force these all the time. Remember, I only have to brute force one. So I don't brute force the main core router or switch. I'll go pick the router or switch that's off in some other location that's not protected nearly as well, where they don't know what's going on. And so what TR said is we're going to block UDP port 161. That's fine from the edge. Are you blocking it against all of the devices that are out there? Because what I'm going to do is I'm going to go after your phone when you're in the coffee shop, and then you're going to take your phone back inside of that organization, and then I'm going to listen off of your phone. I'm going to connect to the wireless network. I'm going to have an authenticated credential, and then I'm going to listen for that SNMP 161 internally and get you to send that stuff to me on your phone. Your appliance should be configured to restrict access to SNMP from only certain IP addresses. AD, I agree with you. That's the security pose on it. That's the person who knows what they're doing from a security standpoint. But remember, the person that went from this job to this job to this job to this job, they're just trying to get their job done. And that's what we're looking for. We're looking for, go all the way back to the beginning of this conversation. We're looking for poor user implementation. But I agree with you. The security controls, because I take this hat off. I mean, I've got the horns on today. I'm a CISSP, and I teach people all the time. Go in there and do not allow somebody who worked with SNMP at their last job to go ahead and manage it at this job without sending them away to SNMP school on this particular product. Make sure that they know all those configurations and are heavy on the security, and we do these kinds of things. So I'm with you. But what I'm saying is my experience is most people screw this up. Okay, last one that I'm going to do here, and then I'll take questions on any. For LDAP, remember the client connects to the server, so this is internally typically. When they first set up their communication, all communications start off with anonymous for initial connection. And you go, oh my God, I got in. And then further authentication kicks in on you. That further authentication usually is just sending back a TLS certificate. It's not any kind of heavy duty encryption there. It's usually station to station, client to server. A lot of the stuff that's transmitted back is transmitted in plain text, but if they ask for the higher level encryption, then the sniffable goes away. So you start with one user, one password, you work your way through them until they lock out, or you try and brute force. Remember, user accounts have to have lockout on them. Now, from a defender standpoint, we should not be using service accounts. And if we're using service accounts, those strings should be really long. The reality is they're using service accounts, and we as attackers can find those service accounts and abuse them, and they can't be locked out. So we can brute force for a really long time against those. And we may even pick up that information somewhere else. The standard way to encrypt is what's called start TLS, and that's the standard certificate sent. This is the weirdness here. There is something for two-factor authentication, and then what that means is that a certificate needs to be installed on the local workstation for the workstation to prove its identity. So there's a TLS certificate installed there, and on the server, and they transmit back and forth. And that's great. But remember what I said about two-factor authentication? You run away. Don't forget that there's container by container permissions and policies for Windows objects that are out there. If we can get access to the containers, we shouldn't just assume that the same policy is across all of those different devices for all of those different users. We may only be able to, from an LDAP standpoint, be able to list the containers. And that's all the tool will allow us to do. It'll show you all the directory structures, but it won't show you any of the leaf objects, the computers, users, or whatever else there is that it's going to display. So you may be able to walk the directory, find out the infrastructure, and that's it. That's good. That's enumeration of the structure of the organization. Here's where you're going to get caught. You're going to get caught with logging. That's just the way it is. They're going to log it locally. They're going to transmit those logs up into some sort of tool that's log aggregation, whatever that is for that company. And then that's also going to trip alarms. So when they see lots and lots of failed authentications on a on the entire container basis, or they see you walking the tree, they're going to catch you at that, and they're going to start booting you out. Remember what we talked about yesterday. It has to be configured to log. They have to be reviewing the log in a timely fashion, and we know that the number is 200 days. 200 days to incident response. That's the average that's out there. You're testing against the average. Now, what I did with this mind map was I gave you protocols and techniques for the ones that were tops on my list. So I've given you those techniques here that we won't cover each individual one. I wanted to talk about RPC port mapper just for a second. This one, a lot of people say, oh, well, I'll go ahead and I'll do RPC and I'll find out what are the listening services on that side. Like if you do, Netstat, and you on your local machine, it'll list off all the listening ports. That's what RPC service is. It's actually when you interrogate RPC, you interrogate it with Netstat if you're on the local box. If you don't have local access, you can't do anything here. So that makes it a little tougher, but every once in a while you'll gain access to a machine and RPC is unprotected. The tool that you can use, there's two different ones that are out there. The RPC dump, if you like Python, I do not speak Python, or RPC info. The TR says, so pretty much organization's data hierarchy like a tree structure. Yeah, if they're using Microsoft and there's more than like 50 users, they realize that they have to have containers. And they break, those are called OUs. They break them down. Usually those OUs map to the reporting and the reporting structure, the departments that they have there, and even budgetary structures. And so then you start looking at it and say, who's got the least budget of these departments? From a testing implementation standpoint, you're going to gain artifacts, and these are now critical internal details. If I have my conservative clients make me stop after the enumeration and they say, what did you get? And I go, okay, I enumerated and I found that this service is squawking everything. That service is quiet. That service isn't supposed to be on. You know, and they give you that look. That's the greatest look in the world is that's not supposed to be on. I love that because it's like, okay, I found something, and you go, okay, well, is that in scope or out of scope? We just want to make sure. I give my clients a lot of time to come back to me and say, I want to change the scope. Usually leads to more work. Make sure that if you're doing any of this, that you have some way to encrypt these artifacts so that it doesn't just blather out all that information. In a lot of reports that I do, I obfuscate it until they actually say, I want to see those details. You have to build a mapping strategy. It's not easy. You can't do it on an Excel spreadsheet. The intermediate steps may be internal to them. And remember, anytime that you see that look on their face, they go, or the oh crap look, be prepared for them to say stop, and then you have to be ready for that. Okay, now, we have queried all of these services with valid accounts that we may have gotten in an invalid way. Or we may have queried these with no valid accounts whatsoever and see what the default behavior is. We have not abused any of these services. We've just said, what is there? Now I want you to think about the next level of this. If we were to go over into CVE counts, when we look at the major services that I've talked about right here, look at the numbers next to those. That's the number of particular vulnerabilities, and there are all sorts of different kinds out there, buffer overflows to directory traversal stuff, all different kinds out there for all the different software that's in the database. If I know that there is the service running, then I can go look and find out more information about that service. Sometimes if I have a username and password that worked for that particular service, that allows me to go after one of the low-level attacks that's out there that says you must have user privileges or you must have administrative privileges in order for this attack to work. Well, I have them because I enumerated them from previous, and now I can use them and abuse something in here. This is where we go into the next stage, which is the exploiting. But by knowing that we have credentials, by knowing that those credentials work on those boxes, we can abuse low-level threats, and they now become high-level threats. So the CVE number or the score for that CVE identifier may be like 4 or 5 because it says you must have admin privileges or something like that. Well, I got them from it over there, but it's on a service-by-service basis. So just know that exists. For DNS, I did break it down into the 2 different kinds of DNS that are out there, the MDNS responder and the LLMNR, relatively thin. For SIP, I separated out the VoIP separately from it. You don't need to know these numbers. You need to know them from a thought process standpoint. Now that I've enumerated, now that I got that information, does it lead me to any kind of vulnerabilities that I can use? If I went into SNMP and now I know all the different kinds of Cisco, Juniper, routers, switches that they have, now I can use that to actually do exploits against them. The SNMP told me that you have all these different kinds of Cisco routers with all these different kinds of versions or these Juniper switches and routers out there, and then I'll go to do those exploits. It gives me rich data. From a control standpoint on the protocols, the defender is going to try and limit you, and you have to figure out what the ways around are. For authentication, they're going to put 2-factor authentication in place, and you're going to run away. For SNMP, they're going to remove the agent, what somebody already said. They're going to block. They're going to turn off the service. They're going to change the default community passwords. If they change the default community strings, brute forcing will work. Passive sniffing may work. It depends on how they've configured the other pieces there. Typically, they'll try to upgrade to V3. So if they've had one penetration test against them, that's, by the way, that's one of the questions that I ask. Have you had a previous penetration test? And if the answer is yes, all these real easy to, I go, piece of candy is really what I look at when I do it. I don't know if anybody's seen that meme, but most of those are gone. For DNS, they're going to disable zone transfers. That's all washed away with now DNSSEC. They're going to separate the private and public. For SMTP, for mail, they're going to ignore email messages. I never ignore email messages and spam. They're going to disable the open mail relays. If they have those turned on, usually they get black-holed and they're out of business. And they might even limit the number of accepted connections so brute forcing knocks down. For LDAP, they'll use Start TLS. They'll select different usernames from their email addresses. That may happen. And they'll do account lockout. For server message block, they'll disable, they'll block it, they'll restrict anonymous access. This is all, should all be washed away at this point, but 1 in 5, 1 in 10, somewhere around there, that's usually when I find that cranking up. For tools, remember you need to use 2 tools for fewer false positives. That does not include Nmap scripting and engine and Metasploit, but they work generally together. Let's take a look at my scan results. Now I'm reconnecting here. All it does is make me reconnect. It kicks me out to go ahead and stop refreshing the display. All I'm typing in here is services, and that gives me a list. Now, this list is a little messed up at this point, so what you might want to do is you might want to grab a hold of this window and stretch it out and rewrite the command. So if you stretch it out, oh, sorry, folks. Run the command again. Now I get a nice tight thing. And this tells me that host number 10 gave up all that information. Well, what about the other host? I only got one host here talking back to me. So we have to figure out why 1021 didn't work. If you're doing the old map, I know that this works. I don't know why 21 stopped talking. This is the remember, this is the Linux host that we've gotten information from. So I'm going to go back and I'm going to look at my I'm going to go back and look at my scan from previous to figure out why I don't have 21 inside of here. That's the list of services that I'm giving to the enumeration process, and I will walk across those. Let's see. Okay, taking care of that question there. So let's come back over here. Now, why is this victim? When you looked at that victim right there, why is it different from the real world? What do we normally see in the real world that is different from this? I'll go back over and let you look at it while you've got your Mentimeter up. So take a look at this host. Why is this different from a real world host? I'll give you the hint here is this and then this. Or this and then this. Why is it different from a real world host? If you got nothing, throw me a question mark in the attendee chat. Did 2 web servers is the first key. That was the first hint. Okay, may have 21 open. There's something else, but think about 2-ness. It's okay if you don't know. I'm looking for the advanced students to maybe give me something here. No. No what? Sure, I can show the screen again. I know it's kind of tough to see. So here, let's go beyond 2. Let's not do 21. Let's just do those right there. See if anybody's got it here. Okay, mostly 443, yes, but there's something else that's going on here. Okay, good. That's a configuration. That's a broken configuration. I completely agree. Port 631, maybe. What about 2 services? How many services do you see running on this box, roughly? And how many printers do you know that are running a database? See what I'm getting at? And this is important for advanced when you're doing penetration tests. When you see a host with a whole bunch of different ports open, is that reality? If you got 3 services, how often do you see printers that are running a database service, MySQL, 2 different web servers on 2 different ports? How often do you see that kind of thing happening? Right. Okay, somebody's got the answer. Right. In other words, generally it's, especially with Docker and like Kubernetes and things like that that are out there, we run 1 IP address, 1 port, 1 service. That's what we allow connections to. Okay. And we have a whole, because IP addresses internally, we can map them to thousands of different hosts that are out there and all that good stuff, especially like on AWS, we can have a whole bunch of different internal services, but it's, this service is running at this port with this port open. And we tune this environment to just this one thing. But when you see a host with a whole bunch of different ports open, it's probably a honeypot. It's probably used to convince you, distract you, to make you think. And what they're doing, remember, is if it's got a whole bunch of ports open, probably some other device separate from it is listening to you and watching what you're doing, and it's not a real service. So just be ready for that as one of the big problems that are out there. Generally, we have 1 port, 1 service. Okay, tell me a little bit about the report artifact from this kind of scan. Tell me, give me some information about it. There's 1 service wants to run everything on it. Oh, okay, AD, that's the other thing, yeah. The small clients will do 1 server and wants to run everything on it. Yeah, that's on the small side. When you go into the enterprise, and I'm speaking from the enterprise. What was the server from Microsoft? Small Business Server? Anybody remember Small Business Server? It was a massager, FTP server, fan, temperature cooling agent. It did everything. Container scanning. For scanning, what is the report artifact? Give me specifics about it. Anybody got anything? It's a little bit more than the IP address ports, because that you got that from the scan. The next person's got it. It's actually internal sensitive data. What do we do with the internal sensitive data? Yeah, we would check for vulnerabilities at this point, but it's internal sensitive data. It's like database data. Because remember, when we enumerated it, we said, show me a list of all the servers. Show me a list of all the SNMP agents that are out there. Show me a list of all the SNMP agent configurations that are out there. Show me a list of all the usernames that are inside of this LDAP database. That's sensitive data. It's part of the scan, but the enumeration means that we have to integrate with those services and talk to them. It will generate a plan of action, but it's not a plan of action in and of itself. You'll have to go ahead and do an inference there with your client. One of the things, remember, as penetration testers, we do light suggestions on how to fix these things, but that's not our job. My favorite thing to say about being a penetration tester is I don't have to fix anything. I just fly down and crap all over your work, and then I leave. I get my check for that. So, I mean, that's really what our job is. But we do give a little bit of inference to this. Hey, you need to tighten up in this area. Or the place that I would focus in on, like a lot of times, the answer is implement two-factor authentication across as many services as you possibly can. You know, that's kind of like the general thing. They already knew that. That's already part of their best practices, but they just haven't done it yet. And now I'm just going ahead and saying, if you don't do it, somebody's going to come along and steal all your stuff. Yeah. Okay, so now there are a couple of questions in here. Let's see. Do you need to have a certain experience level before attending any of this? So I can't speak to that. We already took care of that. In the video, you covered lots of ports quickly. Is there a cheat sheet for all those details? Yeah, it's the mind maps that are right there that I'm gonna post after class today. The 4 different sets of CEH mind maps. So it'll be there. You can use that. Do you have a glossary of the port numbers? I'll take care of that in the mind map. Show me with real-time examples, sir. Scan both. I just did that, by the way. I just did that actual scan. Okay. Okay, now these are exam level questions. If you don't get these, I wanted you to know that you're going to take much more data, much more reading, bring all that together. I'm going to show you some reading after this, where you can get some reading and details along with my videos. There's plenty of books out there that I want you to read. So just be ready. Here we go. If you know this, that's great. This is the level of detail that you must have to pass minimally in Nmap. For Nmap, what is the highest and lowest T value, and which do you use when? After this quiz, we will go to a break. It's good to say I don't know in here. And for those who don't know, it becomes a note card. You write down Nmap T values. You just write that down, and then you can fill that in later on. It is 0 through 5. We don't want to say T is the lowest. Well, any value is the lowest. So 0 is aggressive and the highest. I believe it's 5. Okay, rapid scan. 5 is the insane level. So which do you use and when? 0 level, or at the very lowest levels, 1 through 5. I don't think you can do a T0. Really, really slow timing value. If you were to do the 5, you could break the server. That's the first thing. You will definitely get caught by intrusion detection, intrusion prevention systems, because it'll just blather as fast as it can. You'll clog the network with a lot of responses, those kinds of things. You have to be very careful about that. So use T5s almost never. That's kind of the answer to that one. Okay. How many computers are required for a successful either idle or what's called IPID scan, and why? How many computers are required for a successful idle or IPID scan, and why? Nope. Nope. Still looking for the right answer. Anybody else? Anybody else want to try? Five, 10. Okay, you're just guessing at this point. Hang on one second. Let me turn on something to get us a connection here. Let's see that do it. There we go. Okay. After this explanation, we'll go to a break. You have to know the idle scans. Come on now. Stop playing nice. We're going to take a break. Somebody did come up with the answer. I don't know whether that was a guess or whether that was the truth of it. The answer is 3. We're going to talk about it after the break. I want to set something up so that I can diagram it out because we didn't get a lot of good answers here as far as idle scans are concerned. They're a little bit different. With that, I'm going to hand it over to Heidi, and she's going to give us a 5-minute break. And when we come back, we'll discuss idle scans, and then we'll move on to the next section. Thanks, Heidi. I am mute for the break. Welcome back from your break. Okay, I'm going to move myself out of the way for a second and do a little diagram for you here. So normally I sit down. Well, I can sit down in this corner today. I'm not in the way. There we go. Okay. So we've got 3 hosts. One of those hosts is Dean. One of those hosts is Heidi. And the other is student. That's you. I don't want you to know that I'm talking to you. I don't want you to have any knowledge whatsoever. So what I do is I go looking for a host, Heidi, who she's here, she's hanging out, she's doing her thing, but she's making sure that when things break, that she helps us get them fixed. So for the most part, inside of the room itself, she's not doing a lot of activity until we really need her. And that's the focus of an idle scan. Heidi is idle in this message. And so what we're looking at is we're looking at her TCP counters. It's more complicated than that, but it doesn't matter. It's just TCP counters. And if she's idle, they don't increment at all. So she starts out with a counter of 1. And what I do is I send a message to the student. I impersonate Heidi, and I say, Heidi said port, like connect to a port. Who are you going to respond to? You're not going to respond to me because I said Heidi says. So if the port is open, you will reply with usually an ACK. Now, in order to figure out whether that ACK, because I didn't see the ACK, because you sent it to Heidi and not me, and Heidi's on the internet, I'm on the internet, you're on the internet, and we're spread all across the globe at this point. What I do is I send a query to Heidi about her TCP counters. And she says, I have a counter of, and it's incremented, and we're just going to go ahead and say 3. It has been incremented. Normally she's idle, she's not doing anything, so her counter shouldn't move forward. But if you send an ACK to her, that increased her counter, and I know that that port is open. If I do the exact same thing and you don't acknowledge, you send some form of a negative acknowledgement, a NAC. It's some form. It doesn't matter what it is. It's basically you didn't answer anything. Her counter doesn't increase. So when I query her and I say, hey, what's going on, Heidi? She goes, nothing much. Or the counter hasn't increased. And I do this over and over and over again with each one of the ports to figure out whether your ports are open or not. You have no knowledge that I've been sending it because I've been impersonating Heidi all along. Now you have an intrusion detection system going on and you are mad at Heidi. Heidi, why did you do this to me? Why are you interrogating me? And what you do is you block Heidi. You don't block me. So normally what I would do is I would get maybe 1, 2, 3, or 4 ports worth of information that were good for me, and I would have that knowledge. And now I'm connecting to a valid port on this host that looks like normal traffic. That is the general idea behind an idle scan, or an IP-ID scan. So that's why you need 3. It's attacker, victim, idle host. If you watch my videos on it, I talk about my dog Dixie, who isn't doing much. She watches a squirrel video, and you can actually see her on her you can see her on her Raspberry Pi actually doing these things. So she's a pretty incredible dog to be able to go ahead and surf the internet and to watch her squirrel videos. But she only watches the same squirrel video over and over and over again. She downloads it and then she's done. Okay. So let's see. CT, did you get it? You want to ask a different question? And if you want a deeper explanation where I actually give you each one of the states and instances there and be very particular about it, I would say watch the scanning video, watch the scanning section of the video. Okay, so I'll look for something coming back from you, CT. I wanted to talk about the enumeration map. This is the tools map. I'm only talking about one thing here. You've seen how the tools maps work. I wanted to point to something what's called extra and beyond. Now, you'll see in this, it says 99 plus. And what that means is that there's all this other information in there. This is not for the exam. It's not to be played with there. But this was a collection of enumeration functions and tools that I have used over time. Some work, some don't, some are deprecated and blown up. But I put them all inside of this enumeration map because so far, I haven't found any place that really talks about enumeration, and it is a deeper form of scanning. So those, by the way, those maps will be posted up today after the class is over. It'll be the first thing that I do. So I'd like to switch to the next map here. Just to let you know, we have an hour and a half left in this session, and that is a perfect amount of time. I spend a lot of time on enumeration because you can read about all the other things somewhere else. You can find out videos on all the other things out there. Like somebody was telling me, they sent me an email today and said, you know, I'm watching these videos from this place. I'm watching these videos from this place. Please, if you see enumeration anywhere else, please let me know. But I don't see anybody talking about it. So that's why I spend a lot of time on it and look for your questions. Okay. For vulnerability analysis, this is very different from a conceptual standpoint. If we look at the internal business process, a lot of times when I get hired, people don't want a penetration test. They want a vulnerability scan. When that happens, I ask a couple of questions. And the first one is, do you have an agent installed on a machine? Can I install an agent on the machine? And it's either a yes or a no. Some organizations don't allow that to occur. If the answer is yes, then you'll use something like Nessus, OpenVAS, and then there are a whole other host of scanners out there. For your exam, you must either have installed OpenVAS or installed Nessus and done one scan. I actually do a video on the scan to go ahead and see it. You have to know how those interfaces work. You have to work through the labs as far as Nessus is concerned. We cannot do it in class because it takes, just for the email messages back and forth, if you're doing it on the Nessus side of the house, the emails back and forth might take 2 or 3 days to set up to get your temporary 7-day license. There's something new that Nessus has been doing in the last year, which is they give you an automatic license for free on a virtual machine, but then you have to have host to scan against. If the answer is no, you can't install an agent on it, then it's a manual process. It involves Nmap, but much more so than that. This is not what your father used to say to you. My father would always say to me, this is going to hurt you a lot more than it hurts me. Usually what my mother would say is, this is going to hurt me a lot more than it hurts you when I beat your butt. No, it always hurt me more. I was not a good kid. Penetration testing limits the scope. What happens is you walk in and they say, I need a non-lethal test. That means that you can't run exploits against this. They'll say, do a banner grab or do research. And that's the key that EC Council has set us up, and they've done something different. they've said, we realize that a lot of people who think they're going to be penetration testers are actually vulnerability analysts. They look at scans from Nessus and from Nessus, from Nmap, and from OpenBOS, and from other scanners. And they have to be able to interpret that information inside of those scanners and make good business decisions based upon it. So when we look at vulnerability scanning, we say, can we do this active or passive? In some cases, we're just listening. Do we do it internally or externally? Do we do it on a per host basis or across the entire network? That leads us to, when we do these scans, how do we interpret these results? Well, we have to do some form of vulnerability research. And that's looking for the weaknesses that are out there. We're either looking for vulnerabilities, exploits, or patches. So those are the three things that we can look at. Most of the time, you go into your scanner and it says you have all these patches that you need to apply because we found that you are susceptible to these things. Well, is the exploit available or not? You also have to up your game a little bit to know about new products and new technologies that are out there. If we go back, 5 to 7 years, nobody had ever heard of Slack before. Very few people had heard about Discord and the other services that were available, like Discord and Slack, that were out there. I'm not saying that they're the same, I'm not comparing them. But in that very moment, when both of those services were available to end users on our network, they were able to do file sharing a new, different way. And we didn't know whether we could do virus scans against those files when they came out of the Slack client and onto the local workstation. We actually could, but sometimes you can't. Our job next is to say how important this is, and this is where the problem that we run into as an external penetration tester is. We say we have to understand this business and what compute drives profit within this organization. So if you're a manufacturing business, then you cannot stop the manufacturing line. So any robotics that you have to run no matter what. And if somebody attacks them and does a ransomware and shuts down your human resources services and stops payroll, you don't care. You're like, we'll cut manual checks to the people that are working in the factory. As long as they didn't touch the robotics things that are generating the widgets that we're selling on the open market, we don't care. And so I don't know that going in unless I do a lot of questioning of people. When they want a vulnerability scan, I say, okay, since this is kind of open, I need to tell you about these new things. I need to tell you about what's going on here. You need to tell me about your business. We collect up all those vulnerabilities and we apply a scoring system. That's the CVSS. We as penetration testers, as outsiders on most organizations that don't understand the entire business, just because we say that that's a really high score doesn't mean it's really important to them. Because let's say that their business is predominantly driven by Linux servers and they have a few Windows servers that are out there. Those Windows servers are not production environment. They're sitting over here. They're used for this small task of project management over there that is kind of long-term for us. If we kill that Windows server, we really don't care. So when we look at the numbers for the common vulnerability scoring system between the two of them, if we compare those two, what we'll find out is something that's a lot lower number score on the Linux side of the house for this organization is really, really important as compared to that part right there. Now, if you go into the O'Reilly library, I did a set of recordings on threats and vulnerabilities that's not part of any class here. But it is something that I put up a while ago. It's about 3 hours on the CVSS, the scoring system, and how all of that works. All of that information can be found at first.org, which is the place that builds the scoring system. Just to let you know at this point, take a look here. You'll see that over there in the corner that we're now starting to use the version 4 scoring system that's out there. It has its own calculator. It has a lot of different components in it. I will tell you that the version 3 that is now archived was a lot more difficult to work with. So this common scoring system version 4 is much easier to understand. So that's the scoring system, but you see that number, you have to know what that means. What this requires internally, both for the device that you're using to scan and your brain, is a current database. That database has to be searchable, exportable, and able to be updated in a moment's notice for the latest vulnerabilities that are out there. Usually what you hear this called is some form of a dashboard, and you want reports on this. And this is where it gets dangerous. The vendors for Nessus and OpenVAS say, you, technical person, you do all the scanning. And when you get finished, output your report. Oh, well, wait a minute. We don't know when the manager is going to come and read this report. So what we give is we give you scanning ability and we give manager report running ability. One of the things that they can do is they can run that report and export it to a PDF. This is now a list of their vulnerabilities that they've turned into a PDF. For me, what I do when I go into test, I ask if I can find a vulnerability report, like especially in a penetration test, can I use it? And then I will start looking for anybody that's got manager in their name, and I will start going after them. I will also, sometimes I will go after their credentials if I'm allowed to, and use those credentials to log into the system, because the PDF that I may find may be from 2 or 3 months ago. But if I can log into the system and just read reports off of that scanning system, I can look what the current vulnerabilities are and see how I can take advantage of those current vulnerabilities. So that reporting friendliness and the ability to log in there and generate reports becomes a liability to the organization. So here are your general options that you can look for. You can get a scanner to purchase. You can start looking at common vulnerabilities and exploits from the NIST database. You can look at the CWE top 10, the OWASP top 20, and the CAPAC. That 3-hour thing that I talked about for vulnerability, threats and vulnerabilities, it talks about all those different databases out there. You do not have to have a working knowledge of those databases and how they work for the CEH, but if you are going to be a competent vulnerability analyst for an organization, which is the first job you're going to get as a penetration tester internally, then you must know those databases. You must work with those databases on a regular basis. Now, here's the other thing that gets a little bit weird inside of the EC Council's exam. You have to understand business process. And we're going to just dip our toe into the business process here. We're going to talk about the first thing that we do, which is technical process, is the scan. And that's figuring out the vulnerabilities and mapping those vulnerabilities to mapping those victim systems to potential vulnerabilities. This is where things break. EC Council starts talking about creating pre-assessment baselines that are out there. And as penetration testers, we don't do that unless we're internal to the company. So if you hear creating baselines or pre-assessment, and it's not you asking questions of the client, we're internal to the organization. And that's one of the things that you have to look out for in the setup for a lot of questions. They say, you are an internal penetration tester, but they don't say it like that. They say, you have been creating baselines for the past 6 weeks for this organization. That means that you're internal, but they don't say it like that. So you've got to be looking for that. And that's where this weird business process kicks in. How do you do this actual activity? There are 8 steps in this process. This is something that EC Council wants you to know. But here's the thing. EC Council stops at the 7th thing, okay? And generally, if you go and you look for best practices on creating baselines, there's always this 8th thing, which is right there, and I crossed it out, which is creating protection procedures. Remember? I fly down and crap all over your stuff. I don't go ahead and tell you how to fix it. But in creating true baselines, we create protection procedures for this. And so that's your general set of steps that you do, but EC Council doesn't talk about that one. This is where we do kick in as the penetration tester, as the vulnerability assessor, by doing an actual assessment. This is called scanning. But again, there's some things that EC Council leaves out of it that are important for us. They leave out the physical security environment. There's no talk of lock-picking lawyers or anything like that, or the closest we get is wireless assessments. But remember, you don't have to be on the location to collect those emanations that are flowing out from that organization. So normally we don't do physical security evaluations, but in the real world, somebody goes and jiggles all the locked doors. We don't check for misconfiguration and human errors. How we find out about that is we run the vulnerability scan tools, and inside of some of those scanners, they actually check for misconfiguration and human errors. Some scanners are more robust at this, some are not. It's usually a part of the vulnerability scanning process itself for robust scanners. If you're buying vulnerability scanners, you ask, does it do this kind of scan, this kind of scan, this kind of scan, and this kind of scan? Does it check for misconfigurations based upon my baselines? This fourth one, identifying, prioritizing vulnerabilities, what's the key to that? I'm going to answer your question in a second, RP. The key to that is using the CVE-based scores that are out there and understanding how they apply to this business. When we look at number 5, we're applying the business prioritization to the scanner results. You may have no visibility into that whatsoever. You just don't know. But okay. Then we validate the vulnerabilities. This step 6 usually means that I go in and I send an exploit against that machine as a penetration tester. But like my commercial clients that are in, we'll call it finance, they never want me to validate those vulnerabilities. They say, we'll have to go to each one of the machines and look and see if that patch is on there or if it's not, because the patch could be on it and it could be misreporting. We get a false positive. They don't ever want me to go ahead and they want me to go, that's an awful ugly looking wound right there. But what they don't want me to do is say, hey, does it hurt when I stick my finger in that? Because it's financial systems and they're like a little bit scared there. And we create the vulnerability scanning report. No, we click the scan, we run the scan, and somebody else runs the report for themselves. So I give you all the information there, but realize that it's a little bit different. Post-assessment. EC Council does not talk about this, but in the vulnerability assessment, there is always a post-assessment, and it breaks down into what looks like risk assessments. That's assessing, remediating, verifying, and monitoring. I give that for completeness sake here, but EC Council does not talk about post-assessments and what you're doing there. This is where all the meetings take place that are wasting a lot of time for technical people because they have to go to a change configuration review board, what do they call it, CMB or CBM? I can never get that right. Okay, so now let's see. RP says, what is the difference between a CVSS and a VRP? I don't know what a VRP is. I don't know. Where are you getting VRP from? That's foreign to me, RP. So sorry. Okay. Core terms. You have to know what CVSS is, CVE is, and CWE. You don't have to know the intimate details of them for this exam. You have to know how to separate them out, compare and contrast the general nature of them. So for the steps and techniques, you're going to use a paid scanner most of the priority rating. Is that by a particular vendor? Oh yeah, that's a tenable thing. It's not everybody does that. They're trying, I think what they're trying to do is they're trying to apply the business context to it. That's what there is. Yes, that's specific to them. I don't know that other vendors, and please tell me, RP or others, do other vendors use vulnerability priority rating? It's not part of an exam thing that they can do. It's business context. Okay. For paid scanners, it's pretty straightforward. They're going to give you data, but they're not going to give you business context. And then here's what kicks in at this point. Usually you'll hear, well, we need a GRC tool, that's governance, risk, and compliance tool, to help us with this paid scanner result. They don't do it either. They attempt to, but they don't do that. Okay. Okay, you won. Are you saying yes to a vulnerability priority rating? And are you saying that it's on another product besides Nessus? Now, when we do that paid scanner, that's that inference-based assessment. It is subject to false positives. The machine reports that it has the patch when it doesn't, or it says, I don't have the patch, and it does. It is subject to false positives and false negatives. Now, this is the part that hurts you more than it hurts me, and I just give you an introduction to this system of what you need to do when you can't use a scanner. This is when I get paid a lot of money to watch paint dry, okay? Because it's a lot of very tedious, slow work. So in number one, I do the Nmap scan, and then I build an asset map. And then I go in further and I start using the Nmap scripting engine. I output all of that stuff to a file, and then this is where the real work kicks in. Again, no context. What I do is I go into research databases, and those research databases break down into one of three things. They're vulnerabilities, which we've talked about, exploits, and patches. For vulnerabilities, somebody says, yes, this is very important. For exploits, it says, not only is it very important, but any person with Metasploit or basic knowledge can go get this exploit and apply it to this organization and break their security. There might not be a patch out there. So now what we have to do is we have to go to the research database of patches, and we have to look at the patches and say, is there a patch for this? A lot of times we'll have a vulnerability, it'll be reported, and we'll have a patch right next to it. It's a bang, bang. But every once in a while, we have a vulnerability, there is no patch for it. They give us a workaround, and that workaround is poor. Okay. For patches, the problem with this, and I've been dealing with a group that is dealing with both vulnerabilities and patching strategies on a global level, because, by the way, the common vulnerability scoring system is robust. The CVE identifiers that list all of the vulnerabilities that are out there, last year it was 45,000. And we figure for the cloud side of the house and for the other software that's out there, that the people that I'm working with, we think that that's an order of magnitude or more off. We believe that there's at least 5 million vulnerabilities that were identified last year for all the different hardware and software when we start including all of the cloud environments that are out there. So you have to go look in all these different vendor databases that are out there. Normally what we do is we look inside of the CVE, and I'll drill into one right here. We look inside of here. Oh, it's going to make me go over to the new one. Let's see. So I'm going to pick one at random here. I'm going to search for Eternal Blue. If I could spell. Okay. And it didn't give me anything eternal blue. It gave me eternal CVE. I'm just picking one at random here, 4161. When I look at this particular vulnerability, I go into the National Vulnerability Database and I'll look for it. It will tell me what the CVE severity is, references and advisories, and right there, and I just randomly got lucky here. I didn't plan this. I just clicked on anything. It says, for this particular failure, there is a patch available from the vendor. Sometimes you don't even have that patch in there. Sometimes you have to go ahead and inventory all the different pieces of software in your environment and then have updates coming from the vendors to bring all of this together. And that's the really painful thing. On top of that, there is custom software that your organization is building, or they're taking components from other vendors and bringing them together. And you have to know what those components are and the weaknesses in them. The big one that's out there is the NPM, Node Package Manager, if you're familiar with that one, where all these different vendors write all these different pieces of software that have all these different dependencies inside of NPM. And you have to know about those vulnerabilities and how they impact your final product that's here. That's not an easy thing to do. It's very, very painful, and it takes a long time. And that's not just something that you can populate in most scanners that are out there. So you have to look at it from vulnerabilities, exploits, and patches level, but it's a lot more complicated than they're letting on that most of the vendors will tell you about. The real magic here steps away from the vulnerability analyst and moves over into solving the problem. And this is where your other experience will come in, and that's correlating this to systemic weaknesses. So do we have bad vendors, bad process, or bad infrastructure? I think that takes 4 or 5 years in the field to actually figure that stuff out. That's not an EC Council thing, but that's what you're shooting for at your highest and best use of your time to make yourself valuable to the organization, because otherwise they're going to just think that you're the boy or girl that clicks the button that goes ahead and makes the scans work and slows down work. From a test standpoint, when we're looking at timing on this, it depends on how the organization is set up. From an automation standpoint, it could be anywhere from 4 to 20 hours. If it takes longer than 20 hours, you have an infrastructure problem. You need more tools out there in the field actually running these scans, because you need enough time to run the scan, get the report, get the information, and act on it, maybe patch on it. And if you get the report at the end and you're actually deploying the patches, it's going to take you longer than 4 hours to do that. So now you're on a 24-hour clock and you're never going to catch up. You have to be able to review your assets. When I've done these, we want to limit our scope to scannable assets. And so we have to make that statement. I'm not allowed to scan those devices out there, those robotics things that are out there. In one instance, when I went to an organization, there was a group of IP addresses that were off limits, and they didn't tell me about it. And what it was is when you pinged this IP address, it had a real world effect. It was on a parking garage. And so the signal to make the arm of the gate pop up, and this is a long time ago, was to ping it. So once you pinged it, it just popped open and then closed back down again after a limited amount of time. Every time you pinged it and there was no transaction going in the register, that organization paid the fee, the $7 fee, for letting somebody out for free, right? And so if I sit there and I ping that thing and I just keep on letting it go, they're getting dinged for $7. And if you're doing it to all those arms in all those different parking lot areas of a very large 60,000, they have 60,000 people in their location on a daily basis going in and out. That's a lot of money. So sometimes what you have to do is you have to say, hey, we're going to limit our scope here. Are there any off limits things? And you can use, for instance, you can use that as an example to say, I heard Dean say that, the This could have a real world effect if we have an IP addressable gate. And they probably don't have those anymore. Probably nobody's using those anymore, but there's something like that in your environment. From a business standpoint, the report has good artifacts that are CVE identifiers, naming those particular machines. If I can get a hold of that report from somebody who has printed a PDF and left it somewhere, or stored it somewhere, or sent an email somewhere, I'm going to use that to abuse that organization. From a threats standpoint, can I log in to the scanner as an attacker? Or am I the person on that? If you are a scanner administrator, in other words, you run unnecessary scanner out there and you're handing out those accounts, you have an account management issue and you have a least privilege issue, you should be trimming accounts as quickly as you possibly can. I know that that's not a lot of fun, but that's going to make your environment more secure. I would not allow outputs. I would make everything populate on the screen. And when they talk about reporting for this, you should figure out how to obscure that reporting. People are going to find or fish the reports. Generally, what they do is they create a PDF output of this and they don't encrypt it. And so unencrypted reports are a threat. For controls, on the network side of things, what you'll hear is these things: use a simple packet filter, traffic shaping, data loss prevention. Those things only work to slow down an adversary. On the host-based side of things, you'll hear people say stacked heap protections, whitelisting, and AV filtering and behavior analysis. They only make us slow down. Let's see, that brings us right to the top of the hour for vulnerability analysis. Excuse me. When we come back from our break, we are going to do some vulnerability analysis. So let me get set up for it. I've done the enumeration. Okay. Okay, hang on one second. We'll do the exam level questions when we come back, and then after that, we will do a vulnerability assessment lab. That lab can be done with a browser, and I'm going to have that populated, and I'll put that link from the GitHub into your chat for when we come back. For now, I want you to run away and go play. 5 minutes. Heidi's going to set up a break for us, and I'm going to be mute for the break. I don't know if anybody was watching me during the break. I don't know if you saw it, but I was going in. We had a problem with the permissions. And you'll notice I click Save Changes on these images. And then every once in a while, I don't know why this happens. And maybe it's a Dean thing. Maybe I'm not clicking correctly. Maybe I'm botching it. But I set them all to public because I actually ran the test this morning with my external account. And they worked. And then when I went to go look at them now, they were all set to private. I have no idea why. I might have messed something up. But now the permissions are changed to public. It will take about 5 minutes for that to replicate throughout everything. I've tested that before. When I instantly change them to public, I think that they're automatically working. So the permissions are changed. You can see them on the screen right behind my big fat head. Okay. So that should take care of that. Now, I've given you a link to a lab that we're going to focus in on now. We're gonna do a vulnerability management lab. And the reason why this happened, we have a little bit less than an hour to spend together. The reason why I'm changing this up and doing this is I had talked to a bunch of the people who had come to the 4-day class and the people who come to the 2-day class. And some of the people the people that went to both said, after they went and took their test, that vulnerability lab is a really, really good idea for all the people that are doing this. And if they don't go to the 2-day class, they miss out on this. So that's why I've kind of rearranged things a little bit here to make sure that we get access to that. Let's see. Tool's going to blow up. There we go. Now I got power. So I've given you that link there, and we're going to do this lab together. By the way, the 2-day version of this class is very different. So you might want to come to Wednesday if you want to learn about passwords. That's the fundamentals of penetration testing. It's a 4-hour class. I think it's April. I don't think it's April 1st. I think it's like the April 2nd and 3rd. So coming around to next month, I will be doing the 2-day CEH class, which again is very different than this 4-day class. And I will do this lab again there. It's so important that we do it twice. And I think it's very valuable also from a real world standpoint. So let's actually get into this lab. You're going to go into your GitHub and you're going to click that link. And I'm just going to copy that link over. And I'm going to put that into my browser here. Okay, and so there is that lab. Now, it's very simple how you do this lab. It's easy to say, it's difficult to do. So once you've landed there, what I'd like you to do is I'd like you to, for each one of these links right here, I want you to, and I just look at the links that I'm clicking on. I want you to right click on number 1 and open in a new tab. Number 2, open in a new tab. Number 3, open in a new tab. And because you all are past the basic stages here, I want you to choose the advanced. So don't choose number 4, choose advanced, which is Sploitus, open in a new tab. I don't want you to choose the 3456, I want you to go down to CX Security, right click, and open in a new tab. So now what you have in front of you is you have 5 new tabs. Let's see. You have CX, Sploitus, Wikipedia, a CVE identifier, and another CVE identifier. If you've got the tabs open, throw me an exclamation point into the chat. Okay, it looks like that's flowing in. Now, here's what you're going to do. I'm going to do it directly after you, but I'm going to give you 5 minutes to do this. Now, I'm only giving you 5 minutes because I have to figure out a way to create pressure. Your job is to take these different things, and I want you to imagine either the job that you are in now or the last job that you are in and the devices that they have. And I don't want to know about those devices, okay? But what I want you to do is I want you to reorganize these tabs in order of importance for your organization. I want you to provide business context to these particular exploits that are available to you there. That's number one. Number two, I've just given you 2 CVE identifiers because that gives you consistency amongst the 2 of them, right? So you can compare apples to apples there when you're looking at those things. But for stage fright, you may have to look up the CVE identifier that's, well, let's see, it's sitting right there. You might have to pick off the CVE identifier to then open that up and say, okay, now I can see the CVE scores. But for Sploitus and for CX security, you've got a little bit different interface that you have to work with. So you might be able to pull up a CVE identifier and line them up and compare them. But now what you have to do is you've got to do that in 5 minutes, and you've got to look for your scores, and then you've got to rank them in importance for your organization. Like, for instance, when I look at Poodle, or no, let's not look at that, Stage Fright. Stage Fright is against, and it says right here, it's against Android operating systems. In my particular environment, Android is forbidden. There are no Android devices whatsoever. So by corporate dictum, there are no Android devices. And if one of those gets compromised, even if we find one on our network, we kick it off of our network. So that's really, really low on my priority list. Some of these other ones are going to be a lot higher. Your job is to rank them. Now, I'm going to give you 5 minutes to rank them. You're just going to rank them in your mind. You're going to set up that ranking. You're going to have that for yourself. And then I'm actually going to go through and do the ranking for my business so that you can see what it looks like. So you have 5 minutes to figure out which ones are high, medium, low, like all the way down the line. Okay? So it's not a 5-minute break. It's a 5-minute timer that I'm going to put up here, and I'm going to mute for that 5 minutes. And so there's the timer running right there on my screen. If you have problems, ask me, but I'm going to mute and step off camera. Who got all 5? What I'd like you to do right now is, if you're done, send me an exclamation point in the attendee chat. If you're not done, tell me how many you have reviewed. Okay. So I'm going to go through it very briefly with you. And I will tell you that I don't look at the scores unless it's a tie. So that's the first thing. So I think I won't get in the way here. So let me turn myself on. There you go. Now I'm on screen. So I will tell you that I don't look at the scores in any cases here unless it's a tie. And that's when I would go ahead and change what I'm doing. So I'm only looking at this from a pure business context. So what I have to do is I have to read about each one of these things. So what is it affecting? I'm trying to figure that piece out here. And I look inside of it, and there's bug track here. And really all I'm doing is looking at the description. Okay. Now this was a susceptibility. I'm going to plus this up so you can read it a little bit better. This was related to what's called the heartbleed bug. So this was an attack against the open SSL library that everybody had this problem. In my organization, we use Apple products and Cisco products. And what this was really, it was a big deal against web servers that were out there, but it was a really big deal against vulnerability against open SSL libraries that was used in VPNs. And so that was a really, really big deal. But what happened was, for me and for our organization, we use a Cisco product, and they didn't use open SSL for the VPN portion of it. However, the administrative console that was used to manage the VPNs actually was using the open SSL library. So our regular VPN connections weren't any problem, but if you knew that the administrative console was available there and you could get connectivity to it, then that's a problem. So this wasn't a big deal for our web servers. It wasn't a big deal for our VPN, except for this one instance. So I'm going to put this on the top of my list. It's going to stay right where it is. Next on my list, when I look at this one, this is called the GNU Bash process, and it was called shell shock, okay? It was about the bash shell. So you were able to modify, basically get access to shell in shell shock. Well, I've got a lot of Unix machines out there, so this is kind of important to me also. So, okay, so I'm going to leave it where it is for right now. Comparing the two, if I'm looking at shell shock versus heartbleed, I would say that shell shock is more important to me. So I'm just going to move it, and you can't see me moving those tabs, but I'm just moving those tabs around for right now. Here, well, you can watch me. There, I'll move the tabs down so you can see. Okay, now, as I said before, stage fright, I know all about this bug. I don't have to go to the CVE. It's a corporate policy. We actually have a kill message for anything that's susceptible to any Android product that's out there. We have a kill message that basically disables that device. And if it hits any of our enterprise mobility management tools that are out there, the first thing it scans for is, what kind of device is this? And it's an Android device. It gets put on you're going out to the internet only, you have no corporate access, period, full stop. And if you're inside of our network and trying to get any kind of other connectivity, then we shut that machine down. So this is absolute all the way at the bottom of my list. Next is we're looking at Sploitus and Poodle. Now I got to do some digging inside of here. So I'm going to look at this one right here, the CVE identifier SSL Poodle. Now, I know you go, well, Dean, this is from 2014. We don't have to worry about it. I was trying to get you to put yourself into the context of all of these things are happening all at once, and you have to make a determination. When I look at SSL Poodle, this is SSL Obsolete Insecure Protocol that has now been taken care of in TLS. Are we a TLS kind of shop, or do we have any devices out there that are using SSL? It happens to be that there are a set of HVAC controllers in a couple of buildings out there, not in manufacturing or not in really important places. And we don't have manufacturing in our business. But there's a couple controllers out there that use this protocol, and we can't get over them. So we're going to have to replace those machines. This is a long-term pain in our butt, because if somebody goes in, they could essentially make all of our workers very unhappy by making them very hot or very cold. Okay, so I'm going to move that one to third on my list right now. Then I go into my last one, which is CX security, and this is Venom, and this is an SQL injection vulnerability. And if we look at it, and I know it's really hard to read this. This is one of the reasons why I don't like CX security, because it's written in green and you have to kind of squint. By the way, this is what, for expsec.us, I picked this particular color because it's a pain in the butt and nobody likes it. So that's why I did it. If I look at the original advisory, that doesn't do me any good. There's no patch available to this thing. Let's see, and I have to be able to figure this out. So what is this thing using? So I'm going to look at this, and it says the software's website, SourceForge Project Venom Board. Okay, so this is the Venom Board SQL injection vulnerability. Well, we don't use that. So again, this is one that's all the way at the bottom of my list. It's going to be an absolute 0 for me. So between it and stage fright, this is more of a server bug, and this is more of a host bug. So I'm pushing stage fright up to the next level, because it's likely that a client's going to come in with this, but it's unlikely that somebody's going to come in and intrude with an SQL server, you know? So I can manage those two things, but they're definitely low on my list. When I look at this one right here, this is a long-term pain in our butt. It is not going to kill us right now, but it's going to make people unhappy. And if we start seeing, and you put out an announcement, if we start seeing lots and lots of air conditioning malfunctions, then we'll look for this. But we turned on intrusion detection mechanisms, and we listened for this because it has a good signature out there, and we listened for SSL Poodle that's out there. By the way, there are a couple of different tools out there that I talk about in the other class that will actually look for the Poodle exploit against your web servers. But again, this was for a very specific subset of controller devices that use this. So, you know, it's kind of off in the distance. Between OpenSSL right here and Shellshock, I put Shellshock first because it dealt with a few of our core tools that we use in our environment that were public facing. And so that's how I ordered these things. It went Shellshock, OpenSSL, which we call Heartbleed. It's there it is right there, Heartbleed right here. Then next on my list was Poodle, then Stage Fright, and then this Venom Board's SQL injection vulnerability was not a problem for us. It was all the way down at the bottom of the list. I had to set a business context. Does this make sense to you how I didn't even look at any of the scoring, but it was critical to us? Not all of these were critical vulnerabilities. If this makes sense to you, give me a yes, that it makes sense of how I did it. If it's causing you problems, then ask your questions. And then we're going to move on to the last section of the day. Questions, problems, issues. If it makes sense, just throw me a yes. If you have problems with it, then let's start talking about them. This is the stuff that you make lots of money being able to do. Okay, nobody's having any problems with this. But I mean, you can make a lot of money doing this, but you have to have a lot of business context to make this work. Otherwise, you're just, and think about the level of, just for like, not for shell shock, but for the other one, think about the level of inspection for Heartbleed to have to actually work. You'd have to know that we weren't susceptible to this OpenSSL library except for in this Cisco administration of our VPN. It wasn't even the VPNs themselves. And what we did was, by the way, we just blocked all access from the outside for a short period of time until we had an update. You got a class for the business side of it. Actually, I have a set of videos that I talk about this. The class would be the CISSP. There's a new, I got approval for a security architecture class, but it won't be out until like the end of summer. So it talks on the architecture side. I think the closest thing I have is like CISSP, but you can also look at the threats and vulnerability class, and it'll help you a little bit with this. But yeah, there isn't a high demand for it. I mean, if you have a demand for it and you see the people in your company have a high demand for it, send an email to support@O'Reilly.com and say, we really would like this class. That's how most classes get born at O'Reilly, is by your demand. Okay, I hope you had a little fun with that. I hope you got really sit there and do that. The high pressure of this comes in when you're looking at thousands of assets and you're looking at thousands of vulnerabilities and you're trying to make sense out of all of this stuff. And somebody comes to you and they go, well, what about this thing right here? Well, wait a minute, that's not in my report. That's the thing that I get back from this. Let's see. I consult on cyber side, but would love to do an ethical hacking side for government business side and things. Yeah, cool. Security architecture. Can you give a very brief explanation? No, I'm sorry, I can't. Just don't have time for it. It is, I will tell you that it is, if you want to learn a little bit about security architecture, I have a class, a set of recordings, CASP+. You can look at, there's a section inside of there that explains the difference between security architecture and security engineering. It's very early in the course, and I set that up pretty good for you. I also have CCSP. I also have another set of videos on CCSP that what I call domain zero stuff, the very beginning stuff on cloud, will also explain that. So I'm sorry I can't go into it today. Let's see. Okay, now, exam level questions. Let's see, there's one question back here. Okay, here you go. You found a high vulnerability during a vulnerability scan, but operations proves that it was previously patched. What is your statement called? We have dissent here. Let's see what a couple of people say. Oh, good. Yeah, so there's ambiguity in my question. Good, MD. I like it. Very good. It's actually, one person's gotten it right. It's called a false positive. You have to know False positive is something's not right, but the operations proves that it was previously patched. So your vulnerability report says it's unpatched. That's a false positive. So your statement is called a false positive. Okay, and that is the answer to this one. And you have to be able to understand the false positives in the context of business there. Here we go. What is the most common method to exploit shell shock vulnerability? And now what you got to do is you got to go back and you got to go look it up. I will give you 60 seconds. Okay, if you put an answer in, did you remember it or look it up? So in the attendee chat, did you remember it or look it up? Some people were like steeped in this. This was a really big deal. A couple of my friends were they went nuts for this. It's a serious problem. Last input here. Okay, it is a CGI script against the Apache web server, the CGI interface. Now we're into social engineering. I'm leaving this here. I'm sorry. I remember from the class I took. Wow. That would have been a lot to get through there. Okay, so I want you to all come over to, I want to talk about vulnerability analysis, the tools section. So I just want to start with this. In order to do vulnerability analysis, you need victims, but you have to ask the question, what do you support? If you're going to do vulnerability analysis, you need multiple machines with vulnerabilities in them. I've only given you 2 machines to do scans against, and I haven't even given you a scanner. Like, you have to install Nessus, either install Nessus on, you can't install Nessus on the Kaylee machine. You can install OpenBoss, and when you type in to search for OpenBoss, by the way, you have to look for Greenbone Vulnerability Manager. The key with this is, if you're going to do a lot of scanning, especially in your own practice lab that you set up, you have to have sufficient memory on the scanning device. The biggest mistake that penetration testers make is they say, I'm going to bring in these little Raspberry Pis or Intel NUCs, and they have a bunch of different ones that are out there. But basically, I'm going to bring in this little device that is going to be used as a scanning agent against these machines. An underpowered device, and therefore the scan takes forever and it can't get it done. On the other side, when you're building this up to see how scanning is going to work, you're going to have to build a set of images that are out there that you can test against to see how they react to this. So how many different OSs do you support? How many different versions of those OSs do you support? Do you have one that's patched versus unpatched so that you can see that you don't get or do get false positives? If you have the ability to install agents versus no agents, and this can get really complicated really quickly. My vulnerability management lab that I use that's set up like this has 18 different machines that are running. And these are only on the server side. I don't even do the client side. If you've got a heavy client presence, then you could have easily 36 machines running and you're going to need a pretty beefy box to actually get them all up and running internally. I will tell you that the way that I get this done is I use a 2019 Apple MacBook Pro with an i9 processor and 64 gigs of RAM, and I can run 20 machines on it. By the way, those right now, and I'm talking about Intel processor, and I run it with VMware. Those right now are going for about $1,100 to $1,500 on eBay. So you can't run, by the way, you cannot run the new Apple Silicon. You can't run VMware on it. It doesn't work just because it's a different processor. Okay, so have to have that stuff in place. And then from an exam standpoint, you get to pick, and it's either going to be Nessus or OpenBOS. It doesn't matter. You can answer your exam questions for each one of those. The time on tool is 2 hours, not including setup and scan time. You need to be poking around in there and doing all the different kinds of scans against that. If you're not putting in 2 hours worth of scan time to learn all the different interfaces, how to actually run a scan, which the interfaces are bizarre. The little magic wand with the little light on it is one thing. And this, you have to learn all of those interfaces. When we meet on next week, I'm going to give you the readings map and explain how you can find good information about OpenBOS and how you would use that. So you get to pick. I say pick OpenBOS. That's my preference, primarily because the Nessus scanner only gives you 7 days, and I can never get everything done I need to get done in 7 days. Plus the fact that when I stand up an OpenBOS scanner, I can let it sit for a really long time, turn it on, pull down my new definition files, and run that scanner again. Unless my client says, I want you to do a scanner test and use this, and then I have to fiddle with that. Okay. Now, social engineering. You will notice that there is a social engineering tools section. There is some advanced reading on social engineering, and in the wild, I'm going to give you something, and I'm going to tell you at the end of this session today, in less than 20 minutes, I'm going to allow you to do social engineering against, if you want to, my real company, Expanding Security, my company itself. And I'll explain the rules for that. You have to agree to the rules and be nice about it. If you don't want to agree to the rules and you don't want to go through that process, you can do social engineering against the expsec.us and any email addresses that you can get there. You can keep on practicing your trade there, and it's an automated thing that'll go back to you. But this lab that I'm offering you here is not part of your exam. It's, can you make social engineering work for you in your organization? Okay, so now let's start with the basics of social engineering and how this works. From a conceptual standpoint, this is the art of convincing people to reveal confidential information, and our targets are users, help desk, technical support, systems administrators. My favorite people to go after when a company has got like 400 people or more is the administrative. It's the CEO of the organization has an administrative assistant. I like going after them because they will get the CEO to react, or they will click on stuff that nobody else will click on. So I like going after what's called the whales there. People don't know that the information that they have and the activities that they do are valuable. And the reason why this works is because most people want to help the helpless. When I go into the airport and I step up and I'm all dressed and pressed and ready to go and I look, nice, I'm treated like cattle. But if I walk up and I've got mustard on my shirt and my hair's going the wrong way and I look a mess and I look kind of helpless, people are nicer to me. You know, I depend upon the kindness of strangers, and they help me, and I don't know why. It's difficult to detect social engineering attempts. And by the way, you should never, ever try to social engineer a flight attendant. You will break out in handcuffs. Don't. That hasn't happened to me. The reason why it works is because every time we create a scenario, and that scenario is found out by the organization, and then the organization trains their people to stop doing that thing because that's bad for you, then the attackers reverse that situation and make it something else. What's the thing called right now? It's called, is it called pig slaughtering or hog slaughtering that's going on right now? That's the thing that's really, really horrific that's out there. Now, I wanted to give you the best resource for reading, and it's not what you think. The best resource for reading this is at CAPAC. It is hands down. There, finally the link worked. And you'll notice that it says domains of attack, parameter injection, identity spoofing, resource location spoofing, action spoofing. See, those things start reaching across the technical nature of this. The one with the manipulation of human behavior, if you drill down into the manipulation of human behavior, it's not really that beefy. But we take two things. We take, like, the tool that you would use is be the Social Engineers Toolkit, SET, and you would back that up with a website that you created that looked like that organization, and then you would use a lot of these components right here to create a plausible explanation along with your script that's up front or your ability to make them click on it, and so that they will click through. And so this really is like one of the best places to go to get social engineering information other than this mind map, which brings me to, let's see. Thank you, SL, thank you very much. Pig butchering, yeah, I couldn't remember what it was called. I knew it had to do with a pig. I mean, I've watched the whole presentation. By the way, the best presentation on it is John Oliver. I just couldn't remember what it was called. Okay, from a methodology standpoint, in the scanning, we look at social media, we collect the names and the org chart and the phone call information. From an exploitation standpoint, we're looking for access, passwords, or the ability to remove controls. Hey, can you turn off your antivirus? For maintaining access, we physically sit on site and want to stay. That's what we're after, or we're just after the passwords. Okay, from a core terms standpoint, we break this down into 3 sections here. And when we look at these, there's only one. Remember, I told you previously that there are some things that the EC Council has that nobody else has. And if you don't know what that thing is, you can't get that question right. They have this thing called reverse social engineering. And I'm going to do an example of reverse social engineering here in the classroom. So your students, Heidi is in charge of everybody in this room, okay? She is really, she's important. Now, at the last break, she said to me in confidence, but I'm going to tell you because she's on a break right now, that you really pissed her off. I have no idea what you did. Now, remember, I'm not an employee of O'Reilly, but, you know, sometimes I have an in with Heidi, and maybe you can tell me the things that you were doing that pissed her off. What were you? Were you texting her? Or were you sending messages in the private chat? Or, you know, what were you doing that was so? What were you doing on your computer? Because I know that she can see what's going on your computer. You know, maybe I can help you with this. Tell me what you were doing. And we start this conversation. And so see, I've set up this pretext of I'm not in charge. I'm just like you. Heidi's above us. I have an in with her. I can help it out. But what happens is I say, what were you doing? And you start telling me information. I don't say, what's your password? Give it to me. I say what you were doing, and you just start flooding me with data because you want to go ahead and get whatever it was that you did to make Heidi mad. You want that to stop. This works in a hierarchical situation where you and I are together, but what I'm convincing you to do is I'm convincing you to give me data because you want to solve your problem. So that's how reverse social engineering works. So the attacker presents themselves as some form of authority. In this case, what I was saying is I have an in with Heidi. And then I can do it after or before offering the information to the attacker. And really what it comes down to is, this is your problem. I'm going to make it go away. Tell me how I can make it go away. There is no perfect definition for it. This is as close as I can get to a perfect definition. Now, the humans-based social engineering breaks down into face-to-face, and you must do what's called pre-texting. That's the key, the pretext of a legitimate person on site. What is the setup for this equation? It comes in a whole bunch of different flavors that are out there. When we talk about vishing, smishing, phishing, all the new ones that are out there, they're all forms of communication. Gain their trust, be their friend, ask someone to help, maybe a little bit of money. Right? Yeah. You're defining it. Is a Nigerian prince some sort of authority? No. In that case, it's greed. SM. Nigerian prince scams are all about, do you want me to release this money to you? So now it's about greed. So it's not the same thing. Okay. So vishing or voice vishing, over helpfulness, help desk, third party, technical support. That's generally what's going on there. And I'm going to give you another way to look at this in just a second here. So computer-based social engineering with the help of computers, and that's what I pointed you to in CAPEC. That's really where that centers where a lot of techniques are going. Now, by the way, this is the first time that we've talked about AI in this class. AI helps you write plausible phishing messages. But more importantly, remember I said that AI doesn't make you smarter. It just makes smart people faster. What I can do now is I can use the AI to generate a personal, tailored, long message to every single different person in the company with all of their personal details that I've gathered from the internet. Not me, but my AI gathers all that information from the internet and makes a plausible script for each and every one of them to give me whatever it is that I want. So AI helps us when we've got something set up and we can collect that data and we use that data against them. That presupposes that all the data that is populated about those users is valid. Remember yesterday I told you about how I create invalid information. So the way we do social engineering is we usually talk about pop-up windows, spam, chat, phishing. That breaks down into the 4 different forms of phishing, and now there's new, what they call it, smishing is the new way to do it. Now, separate from how we do it are the principles. And when we talk about the principles here, I've given you the definitions of each one of these. EC Council doesn't make you compare and contrast these principles. That's not their job, because it's not a social engineering test. But they want you to have a definition of each one of these, and so that gets really close to comparison. The cool thing is that these terms are all really, really, they're encapsulated. So what would happen is if you saw question, blah, 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 social engineering, this most closely relegates to, if you memorize those words right there, then you'll know those are the only ones that are options in a list talking about social engineering. So you don't even have to know the definitions of them. You just have to know that these are the terms because they don't fit anything else that we do in penetration testing, which is really nice. The last one I did want to talk about is the social proofing one. I like this one. Everyone else is doing it. My father used to say to me, if they're all jumping off a bridge, would you jump off a bridge? And actually, in my junior year in high school, one of the activities for football camp was after football camp was over, we would go out to this bridge and jump off this bridge into the water. So yes, I would, Dad. If your friends told you to jump off a bridge, the other way that they say that is get with the program. And by the way, the opposite of this that you want to use as your phrase to go ahead and combat social engineering, because you want to help them, remember, is what you say is, we don't do that here. And it's a nice, polite way that if somebody is not really trying to social engineer you, but you know that that's wrong, you can say, we don't do that here. And it's a really nice way to go ahead and diffuse the entire conversation, social engineering or not. Okay, techniques. So here's how you actually get it done. You research the company target. You've looked at that, dumpster diving websites, employees, tour the company. Touring the company, being an intern is a real great way to do this. Select your victim. You're looking for somebody who is pissed off. I was talking to Heidi before the meeting and she says, yeah, those people are really horrible and I hate them and they're making me do all this stuff. Heidi, we can get at them. Developing a relationship. Selecting the employee. Hey, I'm just like you, you know, Heidi and I, we wear black all the time and we're really cool, you know, so, you know, we're the cool kids. And then exploiting that relationship. Give me your password, Heidi. I know she's sitting on the other side. She's laughing about this and she's saying that's so silly. Okay. But what we're doing is we're collecting that sensitive information. It's a very simple thing to do. From a testing implementation standpoint, you build a professional practice around this. I will tell you that you need to set up your impersonation and your social networking sites that are out there. So you as a professional, you want to start building your fakes now. 5 of each kind, maybe 1 per gender, 1 per industry, and then update monthly or weekly. Now, here's the really cool thing about this. What you can do is you can make general industries that you work in. Like if you're in military, then you would have a profile. If you're in the US military, you would have a profile of all the different major commands out there that you're involved with. And you would have 1 of each of them. And then in your social media profile, you can lie and go, I've changed from, forgive me, people who aren't in the military, I've changed from this MOA to another one, or I've changed and I've gone from being in this particular industry. I'm going to do the same thing. I did public relations in this industry. By the way, public relations is a really good one because it's so vague. And now I'm going to work in this industry as somebody who is doing human resources because I'm just like you. So in your LinkedIn profiles, you can change that you're working for a new company now. Or you can say, you know what, I really want to work for O'Reilly, Heidi. You know, how do I do that? What do I do there? And by changing my profile and then asking her for an invite, that kind of thing, I'm changing what I'm doing to suit the purpose. And people go, well, people change all the time. No, they don't, by the way. I'll just tell you that right now. Nobody changes. Okay. For you, start corrupting yours now. Okay, that's it for this. Now I want to move over to the lab. This 2 separate labs. One is expsec.us. Try and send messages and keep on practicing those messages to those different accounts and see what you get back. Some of them are set up for social engineering. Some of them will give you the wrong information. Some of them will give you the correct information, but you have to tailor your messages. So keep on sending those messages through, practice that skill. It's not an exam skill. This is the next level of it. In my organization, there is a special phone number. Everybody in the organization knows that special phone number. It's not the one that makes this phone ring right here. It's a completely separate number, okay? You are allowed to fish or actually call, pick up the phone and call anybody in my organization, okay? And you want that special phone number. Now, it's not listed and you can't look it up. And if you get my real number from them, the 443 number, that's a fail. You can call it, but don't call it because it's not going to do you any good. If you get my target number, it starts with 512. Everybody knows that I don't have a 512 number. And if you want that special number and they give that to you, you're playing the game. Now, remember, these are real people. These are real people that do a job. So this is how we set this thing up. So they're going to take time out of their day. They know that you're social engineering them, but they're still going to play along. So here's how it works. You start the conversation or the email with the following phrase: "Greetings, Professor," and their full name. So if you were to call Helene Thornton, you're saying to her, "Greetings, Professor Helene Thornton." She's not a professor. She's a CEO of the company. Now, they're going to give you one of two responses. Sorry, wrong number. You want, and they'll give you a 4-digit number. This means that they don't have time right now. I mean, they want to try and they want to do it, but you only get that one attempt with them. They're going to give you a code, and you give that code to me via email. I know that you've attempted to social engineer them and they didn't have time for it, so I kind of rack up those codes with them. If their response is, "Shall we play a game?" Okay, which is from a very important movie that's out there as far as hackers are concerned. This means you've got 3 minutes to social engineer them and get the number. Now, they know you're social engineering them, but they're going to let you work through it because they're very highly trained at this and they want to see how you're doing it, and that's okay. You've got to choose a particular social engineering tactic of the 8 that are out there and stick with it. If you switch tactics, they'll boot you off right away. You've got to use all the data that you recon from my professional life, not expsec.us, but expandingsecurity.com, my LinkedIn profile, and all of those things. So you have to start looking up me, okay? For example, this is not going to work. Dean taught my class on ethical hacking. Can I have the number? No, it's not going to work. You've got to weave the details of your research about Dean Bushmiller into the conversation. It must be a pleasant conversation. Remember, you got 3 minutes. So you got to be snappy about this and make this thing work. At any time, they can say, "Thanks for playing." That means that they've run out of time, okay? So that's it. Any other response means that you're talking to a person who's not part of the game. So if they don't understand professor, they might let you go and they might say, "Shall we play a game?" But if you get some weird response and they don't say, "Shall we play a game?" or they don't understand, and they say, "I'm not a professor," then that means that you're not talking to a person who is a part of this game, because you might call like companies that I work with, and that's viable. So if that happens, you say, "Sorry, I have the wrong person," and wish them a great day. Make them okay. Make them feel good about what they did so that you're not wrecking their day and being mean to them. And go on to the next person. Okay. Now, AD said, "Does this work work during class time, or can we come back later?" Any time at all. And that's the last thing that I'm going to leave you with today. If you have questions about the lab, shoot them to me in an email. I've run completely out of time and I have to hand it back over to Heidi. If you have questions about social engineering, I'll talk to you about them then. I will see you 6 days from now. Heidi,
yes.
take over from here.
Awesome. Thank you so much, Dean. And thank you, everybody, for joining us today. Just a reminder, we did record this class and you can access the recording within 48 hours on the same page where you joined us for class today. Also, please join us again on Monday for week 3 and Tuesday, a week from today, for week 4. And you can access that link on the same page where you joined us today. All right, everybody, have a great day. Bye.